Good morning, everyone. Hope everyone is surviving term one at the moment. We're nearly at the end of it. Um, I guess it's for a lot of people who are in Comp1511 at the moment, uh, you haven't necessarily done a full year at UNSW yet, so you haven't sort of gone through all the ups and downs and all the work that needs to go into doing university in a with a long term feeling rather than just oh my god, I've just got to get through this subject kind of feeling. But you're nearing the end of the first kind of time of work. trying to think of a way of saying it. So congratulations for getting this far. And I think yes, the feeling that I'm hoping that everyone's getting is that you know more about programming now than you did before. So you had some understanding of what you thought it might be. Usually people have some expectation when they sign up for a course, but now you've gotten to a point where you're like, okay, I've seen enough about programming to have an idea about where this might go. An idea about what I can do with it. And my great hope is that you can also say that I can do so much more with computers now than I thought I could do before. So hopefully that's where we're at the moment. Oh, I should also say I'm gonna spruik this again because I think it's important for us in terms of improving and updating the subject as we do it. The My Experience surveys are open. I don't actually have a slide for them here, but you can find links in every single notice that I put out for the past 2 weeks at least, while the survey's been open. There's also a link from your Moodle in the course as well. So if you can. Oh, it's actually in the lab for this week as well, is a request for you to fill out the My Experience survey. So all this kind of stuff, just to try to get everyone to give us some feedback on the course. And it doesn't have to be good, like negative feedback for the course also helps us figure out what's not working for students. We get a lot of people saying, this part of the course really doesn't work for me. It's like, okay, good. We can see that this is either like a really kind of a sticking point for the course, and we need to try to make that smoother for people and things. So it's actually quite important for us to get a course that ends up being a course that people appreciate learning from. That's something that we try to get to at the end. So we're trying to combine, the idea that, yes, what we're teaching you is sort of combined knowledge of decades of experience in the programming industry from several different people. But what we can't necessarily do is see what does this course look like to people who have never studied anything like it before, because this is an intro course. What is this course like for people who have never been to university before? Again, it's potentially, especially now, term one, we think about it, this might be the first thing that people do at university, and so it's actually quite important for people thinking about, all right, I want to get a university degree. Can I keep doing this thing for 3 years? So we have a bit of a responsibility to make this course a good kind of stepping point from the start of university into convincing people to think about how they would become a successful student full time, that kind of thing. So your feedback is really essential for that kind of thing. Please fill out the My Experience survey. You will find links to it in many different places, mostly in the course notices, but also in the lab this week. It's really helpful if you fill that out. Okay. Oh no, we have both Tom K's in chat today. So this is quite funny because whenever there's a conversation with both of these guys in it, it's always hey Tom, and they're both like yes, and it's like no Tom K, and it's like no they're both Tom K. Welcome. Okay, so let's get into what we're talking about today. Quick recap of last week. Last week we introduced As usual, sort of one topic per lecture last week. The first one was abstract data types. We looked at stacks when we were looking at abstract data types, but that's like the idea of abstraction is more important than the individual thing that we're looking at. So it's the idea that when we have something like a multiple file project, we can set it up so that our parts of our program can only see some parts of the rest of our program. And that, when I first say it, may sound a little counterintuitive. It's like, why are we limiting ourselves to only being able to see parts of our program? But the trick is that putting kind of boundaries on what we can see is not actually like stopping us from doing things. It's in a sense stopping us from making mistakes. So if we limit the amount of stuff we have to think about at any one time, we limit the amount of stuff that we can potentially get wrong, because we can only really hold in our mind a certain number of concepts at a time. So it's this idea that between the H file and the other files of the project, the H file is like a boundary where you say, this is the only thing you need to think about. You don't need to think about the details. You don't need to think about the ramifications of the way something was implemented. All you need to do is say that so long as we match up to what's going on in the H file, we can then use what's on either side of that H file. So what we get is, because we only see the header, the data, the sort of raw implementation underneath, doesn't get seen by, say, the main file. This is something that you're probably getting quite familiar with in the assignment now, is that you can provide some capability, but you can't kind of just provide unfettered access to the data. Because if we did that, then you wouldn't have any kind of guarantee that whatever's happening in the main file couldn't just break the kind of elaborately built up data structure that you have. And I thought stacks were quite a good example of that, because stacks have particular rules around how they can be used, but they have to be made from data structures that don't usually have those rules. So an array or a linked list don't necessarily have those rules. But setting ourselves up with the H file that says, no, you can't just access this array or this linked list the way you normally would. You have to call these functions. So adding to it only adds onto one end of it. Removing from it only removes from one end of it. As opposed to stuff that you've probably seen in your labs from now on, is you can definitely get a linked list and then remove from arbitrary positions in it. We did it in lectures as well. You can do the same thing with an array. Obviously, you can start editing any element in the list. But sometimes you don't want that. You want some protections in, and that's why we use stuff like abstract data types. As you get deeper into these things, you will notice that the idea of abstraction goes very, very deep through programming. It's in a lot of other languages as well, depending on how a language has been built, and its kind of philosophy in a sense. Some languages have a very, very big standard library, and some languages have a very small standard library. And it really depends on how much the language is expecting people to customize things for themselves, and the language is expecting people to optimize things for their own purposes, or the language says, no, people aren't going to optimize things for their own purpose. We're going to provide a generic solution which is kind of going to be mostly good enough in most cases. So there's a difference kind of things. Like if the thing's pre-made for you, then it's never going to be quite as fit for purpose as if you make something really, really custom for yourself, because it's going to be like more versatile than it is going to be specialized. And C is the kind of language where things are reasonably specialized, where we do everything ourselves, we manage everything ourselves. And other languages, I'm trying to think of like good examples off the top of my head, but actually, like, first thing I was thinking of was like actually game engines and stuff like that. Like the Unreal Engine has a whole lot of stuff built for you, so you can literally make code in something like that without being a programmer. Like, it's set up in such a way that, like, if you've got a reasonable level of logical thinking, you can figure yourself out around those things. So a lot of sort of pre-made modules that just snap into each other. So it's interesting. So you get, like, that's what abstraction ends up being, is like, how much help do we give people to stop them from kind of breaking their own data, in a sense. We also looked at recursion, and to thank Tom again for his his guest lecture last week. So recursion is about functions calling themselves in an interesting way. So if a function calls itself, it means that before it finishes, it's going to add another copy of itself to the call stack, and so on and so on and so on, until at some point one of these functions finishes, and then they all start cascading, returning back in some way. It's an interesting concept. It's a bit weird because it flips our thinking about the sequence of how our programs run on its head, in a sense. Don't worry too much if this is something where it's like, I have no idea how to use that yet. That's fine. We don't really have the time in 1511 to really provide you with the sandbox you need to really master recursion yet. But bear in mind, it'll come back again later. So this is nearly like, as I said, 1511 is an introduction to programming fundamentals. So it's an introduction to things that might happen in the future. And that is what recursion's one of those things. So we're not going to explicitly be testing recursion in the exam, or we're not actually going to be assessing it at all in the course. But that doesn't make it something that's not useful to teach nor useful to think about. It will definitely be examined in later courses in some way or another. Okay, so let me see what... I guess we've got 2 toms in there, so most questions are going to be getting answered. I think there's a lot of people asking about what's going to be in the exam and stuff like that, and people have been asking about what's going to be in the exam for a couple of weeks now. So it's time to talk about what's in the exam. So I'm going to talk about what we're covering today. We're covering your assessment today, which is the exam format, specific things about the timing, as well as the exact, well, not exact, but pretty close to what each question is supposed to be in the exam, rather than what it actually is. It's going to be like, this one's about this one's about this, etc. And then we're going to start a recap of the course. So people have been talking about wanting to see me play games and stuff like that. So this week you're going to see me speedrun a 10-week course in an hour and a half, or maybe less than an hour and a half, depending on how much time we spend on the exam today. So I'm going to go through and try to show everything. Some of you may notice I did actually credit everyone who I stole a meme from. I went to the meme thread in our discourse, and I grabbed a bunch of memes. I didn't necessarily just I apologize, I can't include everyone because there's too many memes there to include, but mostly I picked them based on the subject matter and stuff. So if you're super keen and you want to try to get a meme in for Friday's lecture, there's still some time. I will be working on replacing the memes in Friday's lecture tomorrow. So if you want to tonight, God, this is going to make the meme thread blow up, but you can put more memes in if you want. Okay. What's in the exam? All the things. Yes. There are some things in the course that aren't in the exam, but you can basically think that there will be pretty much everything that we've taught in the course will be in the exam. So anyone making memes, you'll see which memes I used, and then the memes that pertain to particular subject matter as we're doing the speed run through. So there are memes that were like, I think the largest single subject for memes, I downloaded all of them. The largest single subject for memes was .h, because of that time that I tried to hash include the standard input output library without the .h on it. So I thought that was pretty funny, but I don't think any of those memes are actually going to make it in because they don't have any context for the lecture that's going through the course. So if you do memes about subject material, then chances are they're going to make it in. Well, depending if I get like 100 memes turning up tomorrow. So those people who did memes earlier in the term, they're the ones that got in for today. But anyway, we're not going to talk about the memes until we start going through the speedrun of the course. So let me just get my face out of the way of the text there. Let's talk about the exam. Okay, so the admin details for the exam. This is not the only place you will hear the admin details about the exam. It's going to start looking really familiar because you're going to get these same details over and over again for the next week or so. So 1 p.m. on Saturday, the 1st of May. So yes, I do understand Saturday's a little awkward a time for it, but according to the exams unit, in order to fit everything into 2 weeks, they had to use weekend days to do things, and we put in a polite request for the exam not to be on the weekend, but I think by the time it had already been scheduled, they were like, we can't just move this exam, like, especially because I think this would cause significant clashes with a whole lot of people. There is actually one time overlap, but I'll talk about that later. Okay, so how you will do the exam. So it goes from 1 p.m. to 7 p.m. on Australian Eastern Standard Time, which is Sydney time. So if you're wanting to check exactly what that time is, right now in that time zone, it is 11:15 a.m. So if it happened to be Saturday the 1st of May, today is Wednesday the 19th? No, Wednesday the 21st of April at the moment. But if it was Saturday, the exam would be starting in an hour and 45 minutes. So this will be completed on your own computer at home. You don't have to come into UNSW to do it. I fully understand that there's a significant percentage of our student population that can't physically get to UNSW at the moment because Australia's borders are still closed to international travel due to COVID. Okay, so we will give you some files. You will run terminal commands to be able to get those files. There is a practice run for all of this in the lab this week, so you can actually practice getting the files to work on, submitting the files, auto testing, all that kind of stuff. The auto test and submission will be very familiar to you because it's basically the same system that we're using for labs and the revision exercises and the assignment and stuff like that. We're not making you use significantly different infrastructure for the exam. We're in a sense we're testing you on the same stuff that you've been taught. The expectation for the exam is it's actually a 3-hour exam, but I say here 3 to 5 hours because we understand that when you're at home, you don't have the kind of same sort of isolated laser eye focus that you might have on an exam in person. So when we run our exams in person, you get locked in the room. We don't get locked in. You can go to the bathroom and stuff like that, but you can't use the internet. There is nothing to distract you. There's no furniture around you even or anything like that, right? And it's absolutely silent, and you just do that thing. And so in those conditions, someone can finish the exam in 3 hours. But in the general conditions at home, where I don't know, maybe you have parents who are going to knock on the door and say, "Have you eaten?" Or a sibling who's going to come in and ask you about your favorite TV show, and you'd be like, "I'm a little busy. Can we not do this right now?" So bearing in mind things like that, we pad that out. So we've literally given you twice as much time as we would normally give people in person for this exam, and we've also given you full access to the internet to look stuff up. So it's actually I don't know whether it's actually easier or not, because sometimes looking stuff up on the internet is just going to confuse you further. But at least I think it's a more realistic way of looking at an exam, so see how you go with it. As with everything we've done with labs and assignments, you can submit more than once. We're only going to look at your final submission, but you can submit multiple times so that you can say, I went off and did another question and I came back, but if you don't get a chance to come back to something, then you have a submission in there anyway. So as I said, week 10 labs. Week 10 labs are going to go through the whole sort of like a mini version of the whole exam. It won't have all of the questions, because if this thing takes 3 to 5 hours to do, then that's not the amount of work that should go into a lab. So it's going to have some questions to show you how to answer different parts of them and make sure that you're familiar with the infrastructure. While the exam's running, and even before the exam is running, we will be contacting you via your UNSW email address. So it's very, very good to make sure that your UNSW email address is working. One of the best ways you can check whether that's working or not is every week for the last 10 weeks on Monday, I have sent out an email. So there was a public holiday. So one of them was a Tuesday. So at the start of every week for the last 10 weeks, I have sent an email to your student email address. So that should say something like course notice week something of COMP1511, and it'll have a bunch of stuff from me saying, okay, this is what's happening this week. That was just to keep everyone up to date on how the subject's going. If you can find those emails, that means you're receiving correctly at your UNSW email address, and that's the thing we'll be contacting you about the exam. So, I said a moment ago that the exam gives you full access to the internet. It's not 100% access to the internet, because there's a lot of things you can access via the internet that we still don't consider part of the exam. So, it's open book in that, yes, you can, if you want to, and if you're organized enough, you can collect together all of the subject material that I've taught you and have it ready to use, in a sense. So you can be like, here's Mark's notes on while looping. Here's Mark's notes on and diagrams on adding and removing from linked lists. Here's Mark's notes on command line arguments. That's one that people forget a lot, actually. And those kinds of things. You can have them ready, so you can have them all open in a series of tabs on a browser on something, so that you can be working on it and go, I can look at these when I think I need something, So that's totally fine. You can even Google search random things if you want to, but I should point out that it is still an exam, so it is explicit that there's no communication between students. So there are a lot of things, there's a very active Discord chat. There's probably, I assume, active Facebook Messenger chats and other things like that. So my suggestion is turn that off during the exam, because if you see, if anyone starts, I don't know, it's really unlikely that someone's gonna do this, but people start sharing code. If someone starts sharing code in one of those places and other people use it, then all of those people are gonna end up with 0 marks for what they've used. So it's probably better that you just don't see anything than it is to risk that. I actually saw that happen in one of the first online exams, not for 1511, for another subject, where someone started sharing the answers to the exam question on a Facebook Messenger group, and then nearly the entire exam just had to be scrubbed, because it was 3/4 of the course has seen the answers to the exam questions. That's going to officially mean a plagiarism investigation for 3/4 of the course. And it was whoa. So interesting. It's probably safer if you just don't get involved in communication in that at that point. Obviously, no external help, as in you cannot go and ask. So the worst thing that you can do, because it's really obvious when you do this, is to go on those websites like Stack Overflow and stuff like that, and just literally copy the question and paste it into Stack Overflow and go, can somebody help me do this? Your reputation on Stack Overflow will be tanked immediately, because people go, why are you asking us to do an exam for you? This is your business. You should be working on this yourself. And B, whatever solution comes up as the answer on something like Stack Overflow, we're obviously going to see that as well, and that'll go into our system immediately. So anyone with a significant kind of similarity to that solution is going to be investigated for plagiarism immediately. So it's just don't do it. It's really messy, and it's not really going to help you. So the best way to think about this is this point here. Whatever is on the internet at 1 p.m. just before you see all the questions is fair game. Anything that appears on the internet after the exam has started, especially if someone starts uploading stuff to the internet about it and things like that, that is not to be used, right? Because we're trying to examine you on what you can do. This course is not a what you can Google. It's what you can actually do in terms of programming. So yeah. And again, even within the course, no sharing of code. The only people you can share code with is the 1511 subject staff, and there'll be one point of contact only for that, which is this email address, which is the exam email address. So we had to do this so that if people do need to ask us questions or anything, it's here. Obviously, it's not the same as asking questions normally. It's not the same as the forums or help sessions or anything like that. During an exam, we're trying to find out what you've learned. So we won't ever be teaching anyone anything during the exam. So you can't go in the same way you go to help sessions, say, oh, I have some bugs in my code and they're not working, can you give me a hand? this email address will very, very clearly, the people on the other end of that email address, I'll be one of them, will be saying things like, no, I'm not going to help you with this. This is now the end. We're not in the course anymore. So it'll be like, if you can't figure that out, then you have up until the time limit to figure out what you need to do with that. So this is where we kind of, in a sense, we have been growing you in the nest for 10 weeks, and this is the point where we kick you out of the nest and see if you can fly. So when birds kick their little chicks out of the nest, they don't grab them and fly with them and hold them up in the air. They see if they can fly on their own, and I'm hoping that people can. And the majority of people hopefully will be okay with this. Alright, so some technical details about this. I'm remembering the fact that this lecture is quite long. There's a lot of slides here, so I'm going to have to speed this up a bit. So, UNSW email address, as I said before, make sure this is working. You will get an email, not this week, I think next week sometime, that is just like a preview email saying, this is an email about the exam, and it will give you a link that says this is where you will be able to retrieve the exam questions. That link obviously won't become active until 1 p.m. on the day. There are also commands for getting files, submitting files, and stuff like that, but check all of that in the lab. So the week 10 lab is going to have all the information and a practice run of it. So you're going to have this command 1511 fetch prac exam, and then in the exam it'll be different. It'll probably not say prac. I don't know, Tom, if these are the exact commands that are in the lab right now, but I'm pretty sure that would be it. Someone's asking about how we detect plagiarism. There's lots of details in there. We're not really going to talk about it. But yes, obviously we have ways. Every subject has, by requirement, been forced to figure out if people are working together on things or getting answers from other places or anything. Tom said yes, they are the exact commands, and no, we're not hacking you. Also, like, there's been a lot of like little fiddliness about online exams, about taking over people's computers and their webcams and stuff, and there is software that does that. We're not using that. We are, to a certain level, trusting you to work on your own, but we also in a sense trust that we know code well enough that if two people have been working together on code, it's pretty obvious. So, you know, that's all I'm going to say about that. Yes, we have ways, but we're not invading your privacy. We're not going to be looking through your webcams into your home or anything like that. I'm personally very against that idea. Like, if people want to turn on their webcams in tutorials and labs and stuff like that, totally fine. But we're never going to make it a requirement that we see into your home for you to be able to do the exam. I find that a bit weird and a bit creepy, frankly. Okay, so the exam format itself. The questions that there are going to be. So this is exactly the layout of the exam. I'm going to talk through it now and talk about it. So there are 20 short answer questions, theory questions. So these short answer questions, some of them are multiple choice, which is like a reasonably easy way for you to answer things where you just have to pick between options, right? It's not that great in terms of like really being able to tell whether you understand something or not. It's just a statistical idea about whether you do. Some of them are a bit of text. So you'll see some of these questions in the prac exam, and you'll be like, wait, is this really this easy? Where we have some which is just like, what does this code do if you run it? And if you want to, this is like, there's going to be 1 or 2 questions in the course, in the exam, that are like this, where you can literally copy paste the code into your code editor, compile it and run it, and then see what it does. I consider that to be okay, because if I'm going to give 100 marks maximum in the exam, I would expect a baseline capability, so I can give 2 or 3 marks out for the ability to actually type in code and run it and see what the output is and type that in, right? So some of them are that easy. Most of them are not, obviously. Most of them are like, do you understand this concept? So, for example, there might be a looping question, and instead of it being like, what does this type out at the end, I might ask something like, I'm pretty sure this is, I can't remember if this is one of the prac exam questions. I might ask, okay, what happens the third time through this loop? Like, what are the variable values the third time through this loop? And you'd be like, oh, well, there's no way I can just copy paste this code in and see if it runs. I would have to be able to deconstruct that code in some way and say, if this loop runs 3 times, what are its values and stuff? So if you know code well, you can look at it and see how it works, that kind of thing. Other things might be, okay, here's an idea. How would this work in code or something? Well, maybe. That's probably more into these practical questions. So the practical questions, there's only 8 of them, but they're worth more marks each. And each one of those is just genuine programming. And these are really, really similar to the lab questions. If anyone's been working on the revision questions that we've been releasing roughly kind of midweek every week, those go back over previous content in a sense. A lot of those are the same questions that have either been in exams before or are written in exactly the same way that the exam questions are going to be. So that kind of format is there. The lab format's more open. There's plenty of stuff in the labs which is like, oh, here's a cool thing, or here's a stepping stone to something that's more difficult that's later in the lab, right? So they're less self-contained than the revision questions. The revision questions you can see clearly. Someone tagged me there. Yeah, Cameron was asking, all the practical questions are marked evenly. Yes, the 8 practical questions all have the same number of marks. So it's very different from the assignment. The assignment, we heavily weight it towards the things that we know you need to know getting more marks. So it's like, get the first stages done. These are super important. So that's our emphasis there. But here in the exam, it's really just, do you know stuff or not? So basically, we've been learning to swim, and we've been swimming around in the shallow end for quite some time, where there's a lot of support. You can reach the ground, you can climb out anywhere you want. The exam is where we throw you in the deep end and we say, what have you learnt? So instead of like, there's no longer, this is the difference between the exam and everything else in the course. Everything else in the course is like, all of this is a learning experience. We can get something out of this. The exam is like, no, we're not really getting much out of this. We are finding out now exactly how much you know through exhaustive testing. It is a little bit exhaustive. It's only that way because we try to make sure that no one can get 100% in the exam. The reason being, obviously, the more people that got 100% in the exam, every single person who gets 100% in the exam is someone who we're not assessing correctly. Whereas people getting 100% in the assignment is something that I would consider there's a percentage of the course that can do. I would say that the percentage of the course that can get 100% in the exam is 0, and it should be, because we need to figure out how much everyone has learnt. And if everyone runs out of being able to show how much they've learnt, then the exam didn't work. So that's where it is. Don't expect the exam to be easy, because the exam is supposed to test you to your limits, not just be like, oh yeah, that's mostly good enough. All right, you can all have 100%. That doesn't help us or you in any way. You won't get a good assessment out of that. Okay, so 2 types of questions, 20 short questions, 8 practical questions. So here's some sort of more unofficial tips on how to do well in an exam. And I know that like most of you who are here have done exams before. I think most everyone who is in tertiary education has finished high school, which means you've done some exams already. So things to think about. In order to keep concentrating for several hours at a time, you need your brain to have like, you know, a basic level of health to be able to be working on things. So this is like one of the simplest things: drink water. If you don't drink water through the course of the exam, your brain will not be functioning as well by the end as it was in the beginning. Eat decent meals as well. So this exam is starting at 1 p.m. Sydney time. If you're lucky enough to be in the same time zone as the exam, that means you can have lunch and then start the exam afterwards. You don't have to start the exam the second it begins as well. Although I do understand that an exam causes a lot of stress and anxiety. So people are going to want to start it right on the dot. And if you finish early, that's okay. You know, it's probably, more helpful to do it that way. But yes, eat enough to be okay. Don't have like just a massive greasy meal beforehand, because then you're going to end up with like, you know, going to a food coma mid-exam. But blood sugar also affects how well your brain is working, so you kind of know this, right? When you're hungry, you don't think as well. When you've just eaten a heavy meal and you go into a food coma, you don't think as well either. So plan that out, you know. Have a meal that you like, but not one you like too much just beforehand. Also, taking breaks is good. We take a break in the middle of the lecture all the time, and that is something that helps us think about what's going on. Oh, yeah, I apologize. The guy said, what if you are fasting? So we are in Ramadan at the moment, right? So a significant percentage of the people in the course at the moment are fasting. I don't know how much of an issue that is going to be. If you think it's going to be a significant issue and it's something that is going to make this exam not feasible for you, then I suggest getting in touch with us, potentially getting in touch with special consideration and saying that, like, I want to be able to do this at some other time, because we do have a supplementary exam that can be run. I don't know what the university's policy is on this, because I don't know if people are still, like, if you're considered to, like, still be going to work or anything like that. If you would during Ramadan, then, like, this would be considered something that you would have to do anyway, in which case my advice here is probably not that useful to people. Yeah. Okay, so yes, maybe this works, maybe this doesn't. But also taking breaks is definitely something that would work. Also, should say, working continuously for 6 hours is probably not going to be the best for it. Most people, well before the 6 hours, are going to reach a point where they can't increase their marks any further. Like, there is nothing left in the exam that is going to significantly increase their marks. So either you're going to be able to understand what to do and be able to do it, or you're going to say, all right, this is too hard, this is where I stop. And that's totally fine. The exam is set up similarly to the assignments, where it starts easy and gets harder. And so if you reach a point where you go, like, I don't really understand what's going on here, I'm going to have to stop, that's fine. That's the point where you should stop, and you're like, okay, I've done enough there. Hopefully all the questions people are having, Tom is answering there. It looks like he's answering a lot of questions. Yeah, that's fine. All right. In terms of preparation, looking at the list of topics and going through all of the topics in the course and just writing down your own notes about them is really good. This is just really good for remembering things in general, and it's good over the next 2 weeks. I guess it's less than 2 weeks now, 1.5 weeks left before the exam, to at least look at everything in the course and refresh it a little bit. I also suggest that everyone during the exam should have a pen and paper on the desk near them or something. Or if you want to, like I've been doing in the lectures, like something like Microsoft Paint or something like that, which is just like a way to draw diagrams so that you can visualize the solutions to things, right? So that stuff is going to be really helpful for you to, like, quickly get solutions to problems. I always say this, but I understand that no one's really going to believe me, but chill out, it's not a big deal. That is a rather flippant thing to say, so it's not really what I mean when I'm saying this, but this is not the last time that you'll be tested, and this is definitely not the hardest test you'll ever get. So the trick is that the stress that comes from an exam is normal, and it is real, and it is something that I think it's best to acknowledge and deal with, rather than trying to kind of hope that it goes away. So the stress of an exam is going to be the same as the stress you're going to get in job interviews later. It's the stress that you're going to get when you're deep in big projects and deadlines are looming and things, and so it becomes something that you really get to know about, right? And so the more time we spend in, I guess, this like just exposing ourselves to this kind of stress, the better we're going to be able to deal with it in the future. Someone tagged me that. Someone asked whether it's like 6 hours or 24 hours. This is a 6-hour exam. So you literally have 6 hours to submit whatever answers to the questions you can in the exam. So in the past, at some point when we were doing online exams for this course, we had 24 hours, but this one is not. It's only a 6-hour exam. We found that actually people just weren't using the time anyway. Like everyone was finishing within about 3 or 4 hours of starting it. And so, yeah. Okay, so let's look at the detail of the questions themselves. So the short answer questions, these are the quick questions, 1 mark per question. So when you think about it, there's not going to be that much in these. If we think about the other questions being 10 marks per question, they're obviously going to be more work than these. So there's a few things that are going to be asked here. They're going to be checking how well you know the core understanding of several topics in the course. Some of the topics that are not really going to be covered in the practical questions might be asked about here. So a lot of these are going to be either multiple choice or like I would say none of the answers to any of these questions are going to be more than about 20 or 30 characters, right? So they're going to be really, really quick, and they're going to be like, what does this code do, or how does this concept work, or as I said before, partway through this loop at this point, what are the values of the variables? And it could be like, there's a few ways you could do that. If you want to be really, really certain, you could run the code with some debugging statements to do it. But if you know it well enough, you could just look at the code and say, this is where it's going to be. Or it's like, which part of this execution will we reach if we give these inputs and stuff? And it's like a series of if-else statements or something like that. You know, so a lot of little things like that will probably be asked there. We may ask some conceptual stuff as well. So I might say, a stack is a last in, first out data structure. If I, push these 5 elements onto the stack and then pop these 3 elements off the stack, what's the next one that's going to pop off or something? Like I could ask a question like that and you have to say, oh, okay, this is the one I think that comes off next. So all of these things are going to be like, how well do you understand the concepts? And technically, I mean, I don't know if anyone's really fast enough to do this, but technically, because you have all the lecture material, you could do this exam just referencing all the lecture material, but that will probably burn time if you need to learn the concepts during the exam. The point is to have learned the concepts before the exam. So, examples in week 10, I think I can't remember, Tom, how many questions there are in the prac exam this week, because I think there's like 4 of these questions. I'm just ballparking, I can't remember exactly how many there were in it. Yeah, but there's a few of these questions there, and you can see the general flavor of these short answer questions. So, tips of the short answer, there's 3 of them in there, yeah. So tips of the short answer questions. There's going to be a text file that you're going to edit and resubmit that file. The text file has these special triple curly brackets things in it. It's going to be like your answer goes between those. We have a program that's going to read those curly brackets and then extract your answer and then pass that onto the markers in a specific way. So basically, because we're computer science people, our exam is very, very computer sciencey oriented. So yeah, basically only the stuff inside the curly brackets will be accepted. So it's just like programming, right? If the code's not inside the curly brackets, it doesn't work. Right. So yeah, some of these questions have auto tests, and I'm really going to call them auto tests. They're really just validation tests, where if is a multiple choice question with the letters A, B, C, and D, and you put an E in there, it's going to let you know. So this is actually much more polite than most exams are going to be. They're going to say, hey, are you sure about that question? Because that option that you've given that question can't possibly be correct. And you can look through and go, oh, okay, I answered the wrong question. The one afterwards was E, but this one had A, B, C, D. So, like, at least we're throwing you a little bone there where you can actually, like, get a little bit of help. But obviously this is not going to answer the questions for you. It's not going to be nearly as good as an auto test, but it's just going to say, look, the format of the question was this. Are you sure that what you've done is correct? Yeah, so you can see the practice. As Tom said there's questions 1, 2, and a 4 in there. And our 1, 2, and 4 in the exam are probably going to be really similar to the 1, 2, and the 4 that are in the lab. Okay, so just looking... I won't go too deep into the questions there. Tom's answering a lot of them. Okay, so my tips for the short answer questions. Some of these are my tips for an exam in general. Read through them all before answering any of them. This is standard kind of process. And I guess, I said you weren't learning anything from the exam. You actually are learning stuff from the exam, because this is what I would consider standard process for anytime anyone gives me a large amount of work to do. Before I start working on any of it, I will say, what is the big chunk of work that we need to do? What is our overall goal here? Let me skim through the whole thing, and so I can plan how I'm going to work through it. So, read through everything before answering. What I often do is, when I'm looking at a big checklist of things to do, I will have my own document on the side, and I will have like the same numbers, and I'll go, that's easy, that's done. I need to think about this. This one here, I have no idea what's going on, and I'll put a note there going, look this up. I think that this is in this particular lecture about this stuff. This appears to be a question about this, right? So figure out which ones are going to be easy to do, which ones are going to be hard to do, and get those easy marks. Because those easy marks for these warm-up questions are going to take you like 60 seconds each. They're really quick if you know it. So get those, get them out of the way, and then what you do is you thin the herd, and there's less stuff you'd have to think about later. And then you only have to think about, say, I don't know, half of them that you couldn't answer immediately. I don't know. Everyone's going to be different, right? So some people are going to answer half of them. Some people are going to be like, I can answer like 15 of these without even having to think about it. So this is my warm-up, right? And a lot of the short answer questions are really just to get you into the exam environment. They're actually designed by us to sort of ease you in. Some exams might give you a really hard question at the beginning of the exam. That's kind of like a sledgehammer in the face. I don't really need that. I don't need to be like an exam is doing enough psychological damage to students as it is. I don't need to exacerbate that in my exam design as well. So a lot of these, especially from the beginning, are designed to just give you a chance to get involved. So go for the easy ones first, and then look up the harder ones if you need to. Lecture videos, lecture notes, and stuff like that if you have to. Remember, though, that these are a warm-up. Sometimes you might think that, you might say, I'm going to spend half an hour on this, and then 3 hours on the practical questions or something. If you look at the marks, that's feasible. In which case you say, I don't have time to go back and watch lecture videos on this. I'm only going to come back and do that if I feel like I have the time and energy to do it after I've finished the harder questions, which is the practical questions. Okay, so what is in the practical questions? So there's less questions here. There's only 8 of these questions, but they're all worth way more than the short answer questions. So they're worth 10 marks per question. So these are similar to the weekly revision exercises, as I've been mentioning, as well as the labs. They do range in difficulty. So questions 1 through to 8, it's a huge jump from 1 to 8, basically. So if you think about the difference in difficulty of things that we've shown in the course, the early questions are going to be similar to stuff that I've shown in lectures. So stuff that I could do in a lecture in 30 minutes of coding while I'm doing it slowly to show what's happening, and I'm testing it live and stuff like that. So that's going to be the level of difficulty for the early ones. The late ones are going to hit that kind of reasonably hard challenge questions from the labs and stuff like that. So I know, people, there were memes about it, people talking about decimal spiral and stuff like that. That's kind of where the final question will be. It will be somewhere around there. But there's actually an example final question from an old exam. It's not exactly a perfect question, which is why it went into the labs, because the questions that I consider good for the exams stay in the exams, and they get put into a rotation. They may be used again, whatever, that kind of thing, or modified. But there's a question in the lab this week, which is the level 8 kind of question. the reason I took that one out of the exam is it's actually really easy to do if you've learnt a specific technique. So if that meant that like some people who had happened to come across that in high school, whether they had like did some hobby programming or learnt from people in particular, would be able to answer that question easily. And so I didn't like it as much because I considered that if we're going to do stuff to examine how much you've learnt in 1511, I don't want there to be like a trick to solve it that people may have already had before coming into 151. You know, like, it doesn't really make sense. Like, this should be an even playing field. I do fully understand that plenty of people have learnt programming before, and so a lot of those people will sometimes be expecting to do better in this course than other people, but I'm trying to at least level the playing field to a certain extent, where the questions are based on what we've taught, not based on what you may have learned elsewhere. Anyway, so those are the questions. Some of them will have code, some of them will be empty. So we will be testing both things, whether you can work with code that already exists and whether you can work from scratch and build the code files yourself. People are tagging me there. Someone was asking about comments. I think Lorenzo's question... yeah. You said that like the solutions may have been removed from WebCMS. That's probably because you weren't logged in at the time. The questions can only be seen from when you're logged in as a student. There's a question about the second assignment. I think that was just the extension file change in the second assignment, Tom. That's what the rich Russian boy there is asking about. Okay, anyway, let's go back to what we're talking about here. So, every question in the practical questions has to be written, compiled, and tested, right? So it's like a full lab question. So you have to, as much as you can, pass the auto tests and then submit it. The auto tests, as usual, are only tests. The worst thing that you can do here, and I've seen students do this before, is count the auto tests and expect to get marks. Auto tests are not a statistical idea of how well things are going to work. Some auto tests are going to test basic functionality. Some auto tests are going to show you cases you should be testing and aware of. Some auto tests are going to make sure, like, you know how linked lists we were talking about, there's the beginning, the middle, and the end. So some of our questions are going to require you to work with the beginning, middle, and the end of a linked list. And so the auto tests, some of them are going to be the beginning, some of them are going to be in the middle, and some of them are going to be at the end. So you can't just count them and say this is whether I've got the marks for this question or not. It's a matter of the auto test reminding you of things you have or haven't done. The harder a question is, the less auto tests we're going to give you. So if you do want to push for, the highest possible marks in this course, if you're one of those people that's going for basically the unnecessary amount of marks for the course, you have to show that you can code without us telling you what the answers are. So the auto tests are there to prompt people for the issues that might come up in their code. If you want to prove that you understand everything about 1511, then you should be able to code by writing your own tests rather than us having to write the tests for you. Because, you go out there and you make a project of your own that no one else knows anything about, and this is your magnum opus that you're going to reveal to the world in 10 years' time when you finished it. Obviously, no one else is writing tests for you. So it's up to you to be able to write them yourself, if that's where you're going. There is no specific style marking, so you don't have to really explicitly explain what's going on in your code. I would still comment for myself in these things. Some stuff is going to be hand marked if necessary, but a lot of it's going to be auto marked. So if your code, if you can understand what's going on, you don't need to explain it to someone else. So we're getting into like this kind of raw coding here. I would never suggest a code like this in general, but you can code with minimal comments in the exam if you want. There are also hurdles in the exam. So this is the only point in the whole course where your raw marks don't go straight in. Because I don't do any scaling on this course. I just take your raw marks and I type them in and I give them to the university. The only point at which we will not do this is in these hurdles. So there will be one hurdle is based on the use of arrays. So these are data structure based things. So like one's on the use of arrays, but that obviously means you have to use if statements, while loops, and all that kind of stuff. And the other is on linked lists. So you need to be able to do the basics of arrays and linked lists to pass the course. If you can't do either of these, then your mark will be reduced below 50 for the course. So that means you have to get marks of 50% or more in questions 1 or 3. These are both array questions, and you must get 50% or more in either question 2 or 4 as well. This is going to be easier in questions 1 and 2 than it is in 3 or 4, but we have multiple hurdles just in case someone makes a silly mistake in one of the questions, but they do understand what's going on so that they pass it later in one of the other ones. That's rare, because usually with the auto tests and stuff like that, people can tell whether they're passing 1 or 2 or not. These are hurdles that are basic competency things, so they're our genuine understanding of things rather than our advanced working knowledge of these things. So in general, the hurdles, actually I'm going to go through these questions in detail in a second, so I'll tell you what's exactly in these hurdles in a second. But the point is that if you do not pass these particular questions, you cannot pass the course. So that's us saying that what are the basic ideas that you must be able to do in order to work, like in order to kind of continue on in this. So someone's asking like, what kind of questions are the hurdles? Yeah, I'm definitely going to talk about that in just a second. So I would say the best suggestion here, questions 1 and 2, they'll be the easiest ones. So general tips for these questions. I'm going to go into specifics on these questions in a second here. So again, read the problems before starting. So if you read all 8 of them, you can be like, these ones are easy, I can do these. These ones are medium, I'm going to have to draw some diagrams and think about these. And these ones are hard. And also, I know this is a weird thing for me to say, but you can actually cross some of these off. So if you look at, say, questions 7 and 8 and say, these are nuts. This seems to be an unnecessary level of difficulty for where I'm at in this course. You don't even have to attempt them. It's not even that important or relevant. Like, one of the best examples I have, I'm not going to name them because, like, I don't want to name and shame, but one of the tutors at the moment, I spoke to them about this and they said to me, I looked at like question 8 in the exam and I just went, I am not even attempting that. Like, I don't know what's going on there. I'm not attempting that. That person's already gotten an internship with one of the major tech companies. So, like, I think that should give you an idea of where that sits. There is that level of difficulty, and obviously there are other people. Like, there is another tutor who answered all the questions in the exam and got more than 50% in all the questions in the exam. So it's for different people, but it's not necessarily a measure of whether you can do programming or not. It's just how deep you went into it. So anyway, read all the questions. You can pick some that you're definitely going to do. You can pick some where you're like, only if I have time. Or if I get to that point and my brain is still functioning, maybe I'll look at that. But it's best to go in order from the start to the finish. But your own order, you can pick how you go. So use the practice that you've had already. Hopefully you have had practice. Hopefully you've been doing lab exercises, revision exercises, and stuff like that. Being able to debug your own code is important. Being able to test your own code is important. So this, I guess when you think about the time limit, the fact that there is a time limit in the exam is testing how well practiced you are. I think I said this at the very beginning of the course, the idea of like 10,000 hours. We're not even remotely at 10,000 hours. Like, that's going to be like mastery of programming in general. We're at the intro level still. But the amount of practice you have is going to change your approach to things. So the number of like horrible programming situations you've been in before will give you the amount of experience you need to be able to say, I've seen this kind of thing before. Let's look at the kind of process for debugging and go, this is what I'm going to go through to fix this, you know? So if you're practiced enough, stressful situations become less stressful in a sense. So that, if there's anything that I can say over the next 2 weeks, if you get time, is just do some coding if you can. I mean, if you haven't finished the assignment yet, you have no choice. You're gonna have to do some coding. That's going to be good for you, because every time you remove a bug from code, that's better, and that's gonna get you deeper into things. Someone's talking about overlaps in the exams and stuff like that. I'll talk about that in a second. Also, I said this before, don't count the number of auto tests. It has no relevance. The number of auto tests has no relevance. Whether you've passed all of the auto tests or none, maybe, has some relevance. But passing all of the auto tests doesn't guarantee you have to read the question and know that you think that you've implemented this in a good enough way that it's going to do everything that it needs to do. So don't count them. It doesn't help. Like, getting a percentage of auto tests correct only tells you that there are definitely errors in your code if there's any auto tests missing. So that doesn't mean necessarily you're going to get 0 marks if you have partial auto tests, but sometimes it does. Because there are some questions which might be something really simple, like give us a true or false answer. So it's like, I'm never really going to use this question because, like, it's a bit awkward, but like, output 1 if this list is in ascending order, or output 0 if it is in non-ascending order. And so if you want to, you can have no code at all and output 0, and you'll be correct in like 50% of the auto tests, and you'll be like, can I have a pass now? And be like, of course not. You know? So things like that. The auto test thing, if it was just based on auto tests, then people could be stupid and rig it, or they could have made some really fundamental mistakes and not notice that that's happened. Okay, so people are asking about the details of these questions. Let's have a look at the detail of these questions. So, question 1 and 2 are the first hurdles. These are the things that we consider necessary for you to understand to pass the course. If you can't do what's in these questions, you wouldn't have been able to do any of the stages in any of the assignments. That's the level these questions are. They're like kind of not even as much as stage 1 in the assignments. So if you're at that level, you probably already know there's a lot of stuff that you want to do. There's a lot of stuff that you want to learn. This is going to be the actual hurdle, and this hurdle is here to make sure that if you want to take the courses that this course is a prerequisite for, this stuff is going to be assumed knowledge. So it's going to be assumed that you can handle this stuff, and people are not going to teach it to you again. They will just move on to the harder stuff. So if you find that you can't get through these hurdles now, it might mean that you need to do the course again in the future. You need to think about it, or you need to do some more study before you take on other courses, because they're going to hurt a lot if you haven't got these things going. Okay, so the basics you need to do. For the first ones, you need to be able to create C programs. You need to be able to use variables like ints and doubles. This is only ints and doubles. We're not even going to do any of the harder variables. Can you do scanf and printf? Can you do if statements and loops? So the content for the first 2 is roughly like the first 3 weeks of the course, except for one of them is linked lists and one of them is arrays. So one of them is like a little bit harder, one's a little bit easier. So use of arrays of ints and doubles, possibly 2-dimensional arrays. That's question 1. So what we're going to get is this kind of odd even thing in the questions, where the odd questions are about arrays, the even questions are about linked lists, until we get later on in the questions where it's just kind of open and everything happens. So the use of linked lists, so this isn't even the creation of linked lists. There's no insertion or removal. It's just, here's a linked list that already exists. Can you use it? So you can think about these as like, this is also like, here's an array. Can you loop through these? So I'll go through actual examples of these. So this one, if you've done assignment 1, should be reasonably familiar what's going on here. So I have a 2D array here, and I say get some information out of it. So this is basically the format that the question 1 is going to be in. So we have, and this is a format you've seen in the labs before, where we give you a main and a function, and we say just edit the function, don't worry about the main. The main's just a testing thing. So edit this function so that it loops through all the elements of an array. This is a 2D array that's looping through. Then print out every line that has exactly one even number. So this is the input that goes in. You don't even have to process the input. The input gets put into an array itself, but you have to loop through all of the elements of this array and say which of these lines have exactly one even number. So it's like if I do a loop within a loop, where there's a loop that goes through a line, and then it checks for the number of even numbers in a line, for example here, and I can say there's one even number in this line, there's 2 even numbers in this line, and there's 0 even numbers in this line, and I'm supposed to print out every line that has exactly one even number. So this is the only line that I'm printing out, and then I will loop through that line again and print that out there. So this is an example of a question where you're doing one loop through to get some information, and then after you've gotten that information, you're doing something else. Like maybe if you wanted to, you could call a function that printed out the line, or you could actually just go back in the code and go, okay, now that I've seen that this has one even, I print this out. So you can think about like the logic in this code is basically a single loop through this data and collecting some information about that data. It's not just going to be copy paste from the lectures, as you can see. There's a little bit more that you have to do, but that's all it's going to be. So if you know what's going on in the course already, you should be able to do a question like this. Someone was asking about multi-file projects. Multi-file projects are unlikely to feature in the exam in any way at all. So where you can, like, I can't guarantee it because we haven't finished writing all the questions, but I will pretty much guarantee that there's no H files in the exam at all. So nearly everything is just going to be single file projects. Okay, so if you cannot loop through an array, then you need to think really, really carefully about what you want to do, especially what you want to do in the next 2 weeks to make sure that you can handle questions like this. Because I think that if we're at this point after 10 weeks of working on these things, and you don't have the capability yet to work on the arrays, then I think there's a lot of work that needs to be done. Okay, so question 2 is a similar thing with a linked list. So given a linked list, print the difference between the largest and the smallest values. So this is the same thing, where what we're going to be doing is we're going to be looping through once through a set of data, and then trying to figure out some information from this. So there's this list here, 54321, and I have to find the largest and the smallest values in this list, and then just -1 from the other. So this is not too hard because I think that we've already done find largest and find smallest. I don't know if we've done them both already. But if you've been working on the labs, you already know. And also, I think, I don't think we did it in the lectures. We did something different with linked lists in the lectures, but we did inserting based on differences. So there's a little bit of that anyway. But if you can loop through a linked list, which you should be able to do, it takes like 3 lines of code. You should be able to at least loop through and find the biggest or the smallest. You can use your lab code that you've written previously if you need to. So if you've been doing any of the labs, you should at least be able to loop through a linked list. So yeah, find the largest, find the smallest, -1 from the other. That's it. And then just print it out. So you can see the level of difficulty we've got here is the basic necessary level. This doesn't even really test whether you understand how linked lists work. It only tests whether you're capable of looping through one. So I would nearly say that in reality, this hurdle is a bit low. If you can only just make it over this hurdle, then what I'm thinking, 2511 or 2521, I can't remember which subject, that goes on and turns linked lists into like this branching multi-node structures and stuff like that, is going to be really, really hard, right? So that's why these hurdles exist, because if we didn't check for these hurdles, then people would then go on to other subjects that they will have no chance of passing, right? So we want to make sure that you've actually got these capabilities before you move on. So I'm getting tagged in a lot of questions there. Oh, someone's asking multi-file projects. Yeah, could they come up as a concept in the multiple choice questions? Yes, the concept of abstraction is very different from whether you're going to be implementing multi-file projects. So the multi-file projects are definitely, well, not definitely, I didn't say definitely, but highly unlikely to be in the practical questions. But the idea of how to do abstraction and stuff like that is something that we will probably put in the in the short answer questions. Yeah. Okay. So questions 3 and 4, these are hurdle questions, but they're only hurdle questions if you haven't already passed questions 1 and 2. So questions 1 and 2 are I would say the main hurdle questions. Most likely, if anyone can pass questions 3 and 4, they've most likely already passed questions 1 and 2. There is a chance that someone makes a silly mistake in questions 1 and 2 and forgets to auto-test it and then submits it, but they're still capable of doing question 3 and 4. So there's a bit of redundancy for any kind of silly mistakes. So questions 3 and 4 have the same stuff that's in questions 1 and 2. You need to have those capabilities, but what they will do is they will test things to a deeper level. So they will loop through potentially more than once, or they may have a nested loop where they're like, you have to loop through. So an example might be trying to find the difference between one element and all the other elements in a list, which means you have to loop through all the elements, and every time you loop through the elements, you have to loop through the list again and check all the other elements. Something like that, So that's kind of testing more difficult things than the initial questions, which is like just loop through once, and if you get some information, then do something with it. So yeah, this is maybe keeping track of more than one concept at a time, and stuff like that. So with linked lists, we may also do insertion and removal here, which means you need to be able to move pointers around. So you notice that in this one, where we're looping through and getting the difference between the largest and the smallest, you don't actually really need to understand pointers to answer this question. So if you just get the idea of linked lists and you can use the code to loop through, you can pass this question. When you get to question 4, which is the second linked list question in the exam, it's going to be, if you don't understand pointers, it's going to be much harder to do, right? So these are going to get harder as we go along. You don't have to pass questions 3 and 4 to pass the course. You only have to pass one arrays hurdle to pass the course and one linked list hurdle to pass the course. And as I've said, 1 and 2 are probably easier. That's probably a better approach for those. Okay, question 5 and 6, it gets harder, and I think, we're still in the odd even things here, where question 5 is going to be an arrays question, and it's highly likely that once we hit question 5, that we're testing harder stuff, we'll test harder arrays, which are strings. So arrays of characters there, which means you do need to be able to work with strings, which means we're going to start thinking about fgets, fputs, also printf and scanf may be in there somewhere in some way, but also potentially using command line arguments as well. So you need to look up stuff like that if you forget it, or just like, bookmark the references for yourself so you know where to look for them. When we're doing advanced manipulation of linked lists, it's not going to be exactly obvious from the question how the structure should be put together. So it might be more complex. We have to think about, given this question, what is my data structure actually going to look like? So you have to do some planning, maybe some drawing. You will have to do stuff like malloc and free and things like that. Maybe you have to start getting deeper into functions. You may have used functions already in the previous questions. That's totally fine. But here, you're kind of not going to be able to survive without them, in a sense. We might... Actually, I'm not sure if... I just said that we probably weren't. I think that this is unlikely that we're going to use an abstract data type here. If we do use something like an abstract data type, it'll be like a simple version of it, rather than the full multi-file structure there. Actually, potentially could take that point out entirely. Yeah, so... as we got the escalation from questions 1 to 2 into questions 3 and 4, question 5 and 6 again is going to escalate again. So if you've been doing the weekly revision tests, this is kind of revision test question 3. These will range between the hardest lab exercises and the easier challenge exercises. They'll be somewhere around that level. And then we have questions 7 and 8. These are kind of challenge questions for people who are chasing HDs. So basically, if you're trying to get a higher mark than 85 in the course, which is kind of like a little badge that people go for, which is like, whatchamacallit? I know so much about this course that I will probably never need to think about it again. It is second nature to me. Then questions 7 and 8 are your opportunity to prove yourselves there. Tom was mentioning to me there that when I'm talking about might use abstract data types, it's the idea that maybe one of these questions might expect you to be able to build a stack. Whether you go all in and you build it with the specific functions and the type def and stuff like that will be up to you, but whether you can actually kind of understand that this thing needs a specific data type and then use it, I think is the thing there. Okay, so question 7 and 8, everything in the course might be in these questions. So there's a lot of ideas of if I ask you about everything in the course, what I'm saying is, can you join together all of these different concepts in the course into a single program? Can you look at a question that sounds really weird, and then after some time drawing a diagram and understanding what the problem actually is, can you then say, oh, I get it. If I do this array here and I do a struct of this particular kind here, chaining these together in code is going to be able to solve this problem. So what I'm asking in these questions is something along the lines of, these earlier questions are can you write a loop that goes through the elements of this array and does this, right? So I'm not even asking you to solve a problem. I'm just asking you to translate code that I've already basically written in a pseudocode thing. These questions here is just imagine a situation where there are all of the addresses of Anzac Parade and you need to find this particular place, but you only have this information. What do you do? And you go, oh, is that a coding question? It's yeah, it's a coding question. And you're oh, how do I translate this abstract problem into code? That's programming, right? That's the big problem-solving side of programming. All right, so sorry, I'm going a bit overtime here. I was looking at the clock here, saying should have had a break at the moment as well. So yeah, can you break this problem down into parts, and can you solve those different parts? So when we think of questions 7 and 8, it's nearly like if you look at questions 1 and 2, questions 7 and 8 is going to be 5 or 6 of those chained together. You've got to find the right ones on your own and decide what you need to do to make these things work. So the one thing about this is that we're expecting a lot of students to sort of get some way into these, but not necessarily be able to complete them. So there's a little bit more partial completion marks for these. So when I say you can break the problem down into parts and solve the parts of the problem, if you can solve some parts of this problem, there are some marks available here. Whereas for a question like this, if you can solve part of the problem but not all of it, you've probably not solved any of it, because there's so little problem here. So that's the kind of thing where there's less partial marks in the earlier questions than the later questions. Okay, so someone was asking there about how we're going to prepare for this and how we're going to study. I want to talk about how to prepare in general for the exam. The basics are the most important thing. So getting a good understanding of all the different topics in the course is good. So that's why I say an overview of the entire course is better than saying, oh, I'm going to specialize in using arrays, and I'm just going to put all my study and effort into using arrays. That's how you end up doing very badly in linked list questions. I say a broad idea of what's happening in the course is more important. And I said both arrays and linked lists, both of these concepts are fundamental to programming. The idea of, what we call contiguous, next to each other, blocks of memory, is a fundamental idea that has to be used a lot in programming. The idea of nodes and links between them, i.e. the linked list structure, is also super fundamental to programming. Both of them are going to be necessary for a future career in coding. Not necessarily in computer science, by the way. There's a lot of other stuff in computer science than that, but from where we're going at the moment, they're going to be necessary. So that's what we need to do. The things you can do to study is go back and look at the weekly revision tests. There's also questions in the tutorials and labs. There are a bunch of revision questions that are separated by topic. Some of these are pretty old. We don't really have time to go through and check them all and make sure they're all fully up to date and everything, but there's a whole bunch of revision exercises that we're going to release soon. It's just a grab bag of just random questions, but they've also got auto tests and solutions and stuff, so they might be really useful to work on to cover all the fundamentals. Revising with other people is good, and I should point out that there's an event on next week, Tuesday 2 p.m. I think it is. The Women in Tech Society and CSE SOC have organized a study session. I don't have the link to it here, but I think both of those groups on Facebook have a link to that event, and both of those groups have Discords which should have links to that event. So if you look up those student groups, they're running the organized study session on Tuesday. I'm going to be going along to part of that as well, so I will be saying hi and helping people. I will probably also be running a live stream sometime during that week to help people with study. I'm thinking Wednesday or Thursday, haven't decided yet, but I'll let you know when that's happening, so in case people want to just get some final questions in with me next week. Can be nice also to think about the priority for what's important. So things that you definitely need to know to do okay in the exam. Can you use variables? Can you use if statements? Can you loop? Can you use functions? You could get away with not being as great with functions as you are with the other things. Can you use arrays and linked lists, right? So you need to be able to do all this stuff. If you can't do any of these, then there's definitely stuff to look up in the next 2 weeks. Things that you will need to understand to be able to use these things, you'll probably need characters and strings if you're going to do array stuff. But as you've seen, understanding arrays is more important than understanding characters and strings. Pointers, structs, and memory allocation all kind of go into linked lists, but as you've also noticed from what I said earlier, you can pass the linked list hurdle without understanding pointers, structs, and memory allocation. If you just understand the basics of looping through a linked list, that'll do. Yeah, so you don't have to be able to create structs, you don't have to manipulate pointers to be able to do that. You do have to do a tiny bit of pointers, but you won't have to be able to do any memory allocation to pass the hurdles. But you want to get more marks. If you feel like you've already passed the hurdle, you want to go further, you want to learn about these things. These other parts I consider stretch goals. This is like the week 9 content. You are not necessarily going to need abstract data types and multi-file projects. Recursion, we talked about this in the recursion lecture. You either do or don't need it, but that's actually your choice, not mine. So this stuff will get you some marks, but it's not what you need to get over the line. In fact, recursion, you may not use it at all, and that's also fine. I'm wondering if I should go on break. I'm going to go on break now because it's 12:25. So I'm going to go on break and then come back and talk more about the exam. So I want to talk a little bit about human memory when we go on break. So the weird thing about human memory is not based on saving the memory. We put stuff into memory by using it. So the only way stuff goes into our long-term memory is by us using it and us what we do active recall. So if we remember something, the more times we act on the memory of something, the more likely it is to stay there permanently. This is the reason why the lectures happen, then the tutorials happen, the tutorials and labs happen a week after, and then there's those revision tests that happen a week after, and then there's stuff like the reflections which say, can you go back and think about the things that happened before? All that stuff is basically the idea of memory hacking. That's all I've been doing. Like, it's not all I've been doing, but a majority of this course is designed in a way to attempt to memory hack everyone, to basically try to put things into your memory. So all of these things are spaced apart in timing so that the first time you see something, you're probably going to forget most of it. And then a week later when you go into the lab, you're going to be like, I have to try to remember that thing that I saw a week ago. And then if you that attempt at memorizing it is going to actually put more of it into your memory, and so on. You can keep doing this if you want. Anything that you think you might be forgetting, go back and actually go deep enough to do it. Reading about it's not usually enough. You have to actively do something with it. So that means like you do a single question on it where you work through something. That's probably going to make that thing stick in your mind in some way. There's also other ways that you can do this. You can actually like circumvent this process in a sense. I don't know if people have heard of like the mind palace or memory hacking, that kind of thing. It actually totally works. So there are things that you know well. There's the things that you know instinctively. This can be something like the path that you walk each day to go to a bus stop or something, to go to university or something like that. Or even just going in your own front door and walking through your house to your room. There'll be things there that you remember instinctively, well, not instinctively, you just remember automatically because you've done it so many times. You can actually link concepts to those things, and it actually gets you to the point where you can remember things that you shouldn't otherwise be able to remember because you've linked it to things that are already in your memory. So there's some cool stuff like that. Another thing that's really interesting is that your brain is a muscle. And it uses blood like your other muscles do. So actually getting some blood flow, getting up, walking around, moving and stuff actually helps the brain. It's worth in your study breaks where you're studying in the next few weeks to get your blood flowing a little bit one way or another. Usually just going for a walk or something. Everyone's in different countries. I don't know how safe it is for everyone to just be walking out in the streets in every country that is studying COMP1511 at the moment. But, you know, your mileage will vary based on how far you're walking. So that kind of thing. All right, it's 12:27 at the moment. So we'll go on a break now. We'll come back exactly 12:30, and I'll try to squeeze the rest of the lecture in the final half hour. Okay, see you in a sec. Alrighty, we're back. I've put the slides back to where I was up to before the break. Alright, so we've talked about the different topics. I'm gonna have to squeeze a lot into the final half hour here. It's alright, if I don't finish, I will just move stuff into the next lecture, because the recap doesn't all have to be done today or anything. Okay, so marking of the exam. Most of the exam will be auto-marked in the same way that your assignments mostly are auto-marked, but then also there's hand marking as well. So, things to make sure that you work well with the auto-marking is make sure that your input and output format matches the specification exactly. So, I mean, it's going to be pretty obvious when you're auto-testing whether your output is matching correctly or not. The only input thing that is going to catch people out in any way, because most of the questions, like the input's going to be really, really clear. There'll be maybe a question somewhere that takes command line arguments as well as normal input, just to test whether you can use them or not. So that might be there as well. Every hurdle question that does not get over 50%, so anytime there's a chance that someone might be at risk of failing the course for any reason, will be checked by hand. Like, they'll be checked really explicitly to make sure it's like, okay, this person, understands what's going on here, but like left off a semicolon or something. Like, surely at this point you're not submitting things with semicolons missing. Like, you're obviously going to be auto-testing and compiling things with semicolons missing and being, oh, I made a mistake, I'll put the semicolon in, right? So you will, like, but, like, something like that's a little mistake will probably still get you some marks. Again, I can't stress this enough, because, like, people always ask me, it's like, well, I passed 3/4 of the auto tests, how come I didn't get 3/4 of the marks? It's like, it's just not how it works, right? So don't count the auto tests. I have to say this a lot. You get marks for correct code, nothing else. You do not get marks for passing auto tests. You get marks for writing correct code. That's the way we'll be marking it. If you have a minor error, like a typo or something like that, you will lose a few marks. You won't lose everything. Having said that, if you've got a minor error, like a typo or something like that makes your code not work, that shows us that you weren't testing properly, right? Because if you've submitted code that doesn't compile, then you obviously didn't test it, right? So we can't give you full marks for having a good idea about what's going on, but not also be able to take that idea through to completion. So some marks are obviously from being able to complete the code, some marks are for being able to understand the problem and see how to solve it. So you can still get a fair bit of marks for code that doesn't necessarily pass all the auto tests, but has a really, really good idea about how to solve the problem. So that's the way the marking is going to be. It's like, did you understand it, but did you also manage to bring this through to fruition? So if you can get it all the way through to working and you understood how to solve the problem, then you're more likely than not going to get full marks for the question. We're expecting the marks to be ready around the 17th of May. I think that was the Monday 2 weeks after the exam finishes. That's actually the end of the exam period, because we're so early in the exam period. Hopefully we'll have it marked by then. Your official results, I think, go back by the 20th. So it'll be somewhere around the same amount of time. Like, it's so tight, us trying to mark, like, I think at the moment we've got just under 900 people. Trying to mark 900 people in 2 weeks is kind of our own hell. But we put you through hell in the assignments, so we will go through the same to try to get your results back in time. There are... this slide is too busy. There's not much space for my face. Okay, I'll just sneak in the bottom here. Special consideration can be an issue, and it can be something that you might need. Some people already have special consideration set up. So those of you who already have current special consideration cases, you will be given extended time in the exam, or if there's a particular issue, you can sit the supplementary exam instead of the standard exam. A note here, the supplementary exam will be scheduled, hasn't been scheduled yet, in the week of the 24th to the 28th of May. So if you think you need the supplementary exam, please make sure you're available at that time. things that might happen if you don't have an existing special consideration case, but something happens. If you're not well enough to attend the exam, so if you're not well enough to be able to do the exam at the time it happens, don't start it. If you read the questions in the exam, then you're in. And that is the only time you will be able to do the exam. So if you open the exam and you start looking at it, then you have to go through it. Right? Well, you don't have to. If you get really sick during, then get in touch with us, you know. And this is something that we're going to definitely have some situations with online exams. I've seen it before. I've been sent photos of people's crashed computers, broken hardware and stuff like that, and it's just like, okay, cool, we'll deal with that in some way. So the 6 hours is actually made to address a lot of those things, where because you have 6 hours, hardware failure is something that can be dealt with. Like when we've got a 3-hour exam and we're in person, if you have an issue with the hardware, which is our hardware, we will give people an extra sort of 10-15 minutes and move them to another computer, that kind of thing. Because we can't do that for you, what we're hoping is the massive extra amount of time that you have twice the amount of time that students sitting this exam in person would have had, means that you can deal with any of those issues. However, you know, if you have any issues, let us know. The important point, though, is if you're not feeling well and you can't take the exam, do not start it. Yeah. So if you do have a genuine, like if you're sick and you can't do it, in the same way that if you're sick and you wouldn't go to work or something like that, then get special consideration. You are going to need to document this and everything. You can't just go, I'm tired, I'm not going to do the exam. Like if it's not something that special consideration is going to accept, then it's probably not going to work. So the way that the university works is that once you have started the exam, you have acknowledged that you are not sick, and then you are starting the exam. The only issue is if you become sick during the exam, let us know. This is what this email address is for. We have a team of people who are just going to be sitting there watching this email address and answering things as fast as we can for that. So those are the issues that might come up with special consideration. Some people are going to be given extra time and stuff like that as well. Yes, so as I said, if you are sick and can't make the exam, there is another exam. If you're given special consideration, this is not up to me. By the way, the university does this, not me. So they will verify things like medical certificates and stuff like that, and then they will schedule you for the supplementary exam if you're eligible for that. And so that will be happening the week of the 24th to the 28th of May, but I don't know exactly when that's going to be. Okay, so I do know that there is an exam overlap. University's official policy is that people can have 2 exams in one day. There is one really particular overlap, and a couple of people have emailed me about this already, and we know that because there's like 100 people in the course who have this overlap. This is, I can't remember what's the name of the course. It's a finance course or something like that. The exams unit knows about this overlap and has considered it to not be a problem. So they've said that the COMP1511 is a 48-hour exam that starts roughly the same time as our exam. So they don't consider their exam to need 48 hours full time to do. So if you spend the first 4 or 5 hours working on COMP1511, take a break, and then start COMP1100, they consider that you are not disadvantaged by doing that. So yes, they know about this overlap, but it's going to remain as it is. Other than that, as far as I know, I've been told by the exams unit that there are no clashes other than this overlap, and I think there's just one other overlap for I think 1 or 2 students, and those are considered by the exams unit to not be overlaps that are significant enough to reschedule any of the exams. Tom's also saying that he sent a direct email to everyone who is in this particular position to let them know of the situation. Yeah. Yeah, and someone, Yotsuba Des is saying, what if my hardware is faulty? I would say that be careful. You have 2 weeks to figure out what you're going to do there. If you are in Sydney near UNSW, there is the possibility, as Joseph's saying there, of booking out a computer in the library, I think, to be able to do this. I'm not sure what other facilities there are. Yeah, it can be a bit awkward if you really don't think that your hardware is up to it, or you don't think you'll be able to do it. Let us know. I'm not sure exactly what we can do, because this is like, especially if someone's like in another country, there's basically nothing that we can do, because we can't. There's no way we can, like, account for your infrastructure or anything like that there. But there might be something we can do to help. Okay. Last thing about the exam. Anything, if you're in doubt about the exam or anything, this is the email address. It is different from the normal email address. We are not going to be answering exam queries on the COMP1511 admin account. The forums will be turned off during the exam, because we don't want people to accidentally ask questions on the forum and then give away an exam question. Because, like, I think one of the worst things that can happen is, like, on our official channels, someone accidentally broadcasts the code that solves one of the exam questions, and then we have to do really weird things like removing the exam from the course and then somehow scaling the marks to fit back into 100 and stuff like that. Super annoying, right? So anything, you have any problems in the exam, you can ask the exam email address. We will obviously not be helping you to write code or to solve coding problems or anything like that, but any problems in terms of admin or anything like that is fine. Also, there's always, because these exams are written by humans, we may write something that is ambiguous or something that doesn't entirely make sense. So if you ask us about that question, we might do something like send an email to everyone in the exam saying, we've been shown that this question doesn't entirely make sense. We've rewritten this question. Please reload the questions, that kind of thing. Someone saying, should we leave messenger chats or Discord chats before the exam? I don't know whether you necessarily want to leave them or not, but I mean, I'm assuming that all of those chats will go really quiet during the exam. I mean, like, I've heard of it happen before, where someone asks something in one of those chats, and then everyone else who happens to be there at the time just goes, don't talk about that here. Don't talk about that, So it's just like, it's highly unlikely that those chats are going to have any conversation at all, and I think it's probably better just to not have any conversation at all during the exam on those, because it's better if you just make sure that there's no communication happening between you and other students during the exam. Yeah, so whether or not they will, like, stuff like CSOC will turn off part of the Discord server or not, I'm not sure if they will or not. Okay, so that's it about the exam. There's also a lot of information about the exam in the labs this week, so hopefully there's a lot of information there. So going on to the second half, I mean, I think it's fine for me to spend the majority of this lecture on the exam. We're going to be talking about... Oh, that's a really good question from Autumnal Blake there. Can we discuss it later? You can talk about stuff, but don't share code from the exam even after the fact. So I know that if you want to, you can just copy paste all of the questions and then post them up online. Actually, no, if you do that, that's actually plagiarism. Because you don't know if people have a supplementary exam or even a further supplementary exam. You don't know when people are going to be taking this exam. So we do have like just straight out 24 hours, no talking about the exam, like not even talking about the exam. But even after that, if anyone shares code from the exam questions afterwards, then that is also still an issue. So basically, take everything that you did in the exam, the questions for the exam afterwards, and basically delete it all, because it's code that we don't necessarily want going around or anything like that. A lot of these exam questions, we may end up in a situation where we want to use the question again, and it'll really depend on how many people know about that question, because we always edit them. They're never exactly the same question. Again, like you've noticed that in our assignments, they may have the same titles as previous assignments if you've ever seen any historical information about the course, but they won't be the same. And the more that these things are shared around, the much more work we have to do to make new questions and things like that. And the more work we're doing making those, the harder it is for us to get them right and get them actually flowing smoothly. So basically, anytime anyone shares stuff from the course online, it makes the course worse in the future. So it's tough. Like, I mean, like, I can't really stop everyone from doing it. I've made some polite requests of people who accidentally made their GitHub public with the entire of course materials in it and stuff. And even worse situations, I've had times where someone had a public GitHub and someone else submitted their code as like lab solutions and parts of assignments and stuff like that, and retroactively the people who had their stuff public were subject to plagiarism investigations and stuff like that for providing code to new students. So just be careful about all of that kind of stuff. Someone was asking about solutions. No. So this is not, as I said, it's a bit awkward. Exams are awkward. They're not really a learning experience. They're a testing experience. So we won't be releasing solutions afterwards to show you how they were done or anything like that. I should point out one thing about exams and just my personal opinion about exams. I think they're crap. And I would love to be able to do this course without exams. But there's no easy way to look. Okay, so this is how this works. If I wanted to really know how well people could code, if I wanted really, really accurate marks that I could give all of you on how well you're doing with programming, I would sit down with each of you for an afternoon, and I'd spend 3 or 4 hours with you for the afternoon. We'd have a deep, long conversation about programming and what you know, and we'd work through a series of problems together and stuff like that. And at the end of it, I'd give you a mark, and that would be really accurate. It'd be a really good mark. I would finish this sometime around 2025. But you'd get a really perfect, accurate mark. Unfortunately, the university would like me to submit all of your marks in about 3 weeks' time. So it's not going to happen, and so that's why something like the exam has to be done. So it has to be done in like kind of a broadcast manner, rather than a really good kind of one-on-one sort of thing. So it's unfortunate, but it sort of has to happen that way. So I do understand that, like, it's not that great, but what you've gotten in your learning in the course, which is the important thing, has been much better in terms of, like, you've had some one-on-ones with your tutors, you know, so you've actually had some one-on-one learning. The exam, unfortunately, we just can't fit that in. What I can tell you, though, is when you are tested out in the real world, when you finish university and stuff, you will be tested one-on-one. So at no point are you going to get hired for a job without some one-on-one testing. Right, so that kind of genuine look at how you're doing and stuff, you are going to get that in the future. So you will get the level of respect I was not able to give you here, which is the level of respect I think people do deserve. Is you deserve a chance to prove yourself in person, one-on-one with people, to really show what you can and can't do. So you will get that in the future, but unfortunately we couldn't do it here and now. Someone said, fully support the cloning of Mark Cheese just to discard the crappy exam. If humans could be cloned, I would be pretty low on the list of people who should be cloned. So, all right, let's move on, because we've only got 10 minutes left. So we're gonna like speed through. Well, we're not gonna speed through. We're just gonna start at least. We're gonna start the recap. So what I want to do is go through all of the topics that we've learned this term. So all the things. And this is where some of you will see your own names turning up here in the memes, because you put the memes on the forums. So, programming in C. We're at this point now where we started programming in C. And this is the stuff that we've learnt this term. So we're going to look at some of the formal technical topics, and then we're going to look at some of the not C-specific topics, which are actually potentially very important. And we're going to go through all of them. So for the moment, we're going to go through some of the C stuff that was early on. So this is the C language techniques that we taught through the year. So if you want the year, if only we had a year, you'd all be so good at these things, but some of you would be actually most of you would be bored of them by now if we'd spent a whole year on these. Anyway, these are all the individual little topics that we learnt. So they're roughly in the order that I taught them as well. So C is a programming language. It is a compiled language. We were using DCC, but there are other compilers. So there's Clang, GCC. I think DCC actually uses one of these in the back end. Maybe uses Clang for some of its stuff, but GCC, it's definitely using GDBs, which means it's using GCC for some of its stuff, right? So there's lots of stuff. But anyway, all of these things are going to translate our code into something our computer can run. So compilers read the code from top to bottom, and they translate everything into machine code. So you'll notice now this is just revising things. I don't have to explain everything. Hopefully you're just remembering a lot of this stuff. All C programs have a main function. If you want to grab code from other files, you use #include. Compilers are totally happy to be able to do that. They can do multiple C files at once, and they can #include all these other files. So now that we know more about it, I can go back and talk about these things in their reality, rather than the first time I talked about these things where I was really, really careful not to bombard you with too much information. So yeah, here's another one from the forums. Compiling with DCC gives you all of the warnings you need. Compiling with GCC allows you to drive through a fire, potentially exploding the program that you're in. Someone was saying, Edward, who put this up, said this GIF only just fit within the file size limit on the forums. So input output is one of the first things we learned, was just how to put information on the screen, and this was Kangaroo at home. It looks just like a kangaroo, right? It's perfect. Okay, so scanf and printf were some of the first things we learnt. So Tom's saying, confirming that DCC uses Clang, but also GDB and Valgrind. I know it uses Valgrind, yeah, for the memory stuff. So, alright, yeah. I just had to tick that. I don't know why that was moderated out. Blake was just putting a kangaroo picture there. So, scanf and printf are the ability to read from our user and write to our user, those things we call standard input. The pattern strings here allow us to take our data from our program and format it in different ways to be able to look at things. So, really, really simple example. I set up a variable. I haven't talked about variables yet. These things, again, are out of order now because I assume that you know about variables. Someone enters a number, we can scan it into that number, and then we can print it back out, right? I think by now that this stuff is stuff that you can do without having to think too much about it, and it's now that you're actually starting to use these things to even debug other parts of the code. There are alternatives for these inputs and outputs. There's lots of different ways we can do things. We can do individual characters using getchar and putchar. We can also use fgets and fputs to do entire lines of text. So we have many different ways of doing this. Some of them are more effective than others. If you wanted to, you could just use getchar and putchar and nothing else, and you'd be able to do everything. It would just get really, really fiddly. It's nearly like scanf and printf are wrappers around the simple basic functionality in getchar and putchar. So they'll grab a few of them in a row, identify what they are, and then go on. There are also lots of little functions, and this is where input-output has heaps of stuff in its standard library for just assisting you in how to do these things and how to convert between them and stuff like that. We've also done command line arguments, so see where we're going outside of the order that we've done it originally, where when we run the program itself, we can type in the name of the program to run it, and then we can type in things afterwards. So we can type in words afterwards, and they go in a special set of inputs into the program, and this is set up in a very specific way. We'll always name and use these in exactly the same way in our main program. argc is the argument count, the total number of words, including the name of the program that were typed in. And argv is an array of strings. It looks weird, right? Because it's an array of character pointers. But they're considered strings because the character pointer gives us the address of the first letter, and anything we do with strings is going to read through until it hits the null terminator. So each of these things, even though it's a pointer to only one character, it gives us access to a sequence of memory that has characters in it. We'll talk more about characters and strings. I don't know if we'll get to that today. We've only got 5 minutes left, so we're probably not going to get to that today. The code for command line arguments, I think the most important thing is that the int main line, so the actual line for the main function, one main function for every program, will not have a void if you're using the command line arguments. It will have the argc and the argv. So as I said, an array of character pointers. So it's basically an array of addresses where strings start. And we can use this array basically by going, this is a string, and there's argv. I actually used the %s here to print out a string. You can do that in printf. I could have done fputs as well. A warning in case anyone's tried this and destroyed your code. If you do scanf with a %s, things go really weird, because there's a lot of potential for causing significant problems if you do that. So I would suggest never to do that. I use fgets instead. So if I do this program, if it's called args, and I say run args hello world, this thing is able to grab the words and says this had 3 words, argc, the 3 words were, and then it prints them out one at a time like that. So once we're using it, we understand that the argv is an array of strings, so we can use each one of those like an individual word. And we've got our hello world here. This was another meme that came from the forums. It's a cute one. So, variables. This is our way of storing information in memory. So we think about our computer memory as a bank of on-off switches. So each of those on-off switches is a binary digit, a bit. And so what we do is we're going to store our information in this memory using certain types. Now we have heaps of types. The first time I introduced variables, I only gave you 2 types, and even that was confusing enough because I talked about the details about each of these. But now we know we've got characters. We know we've got multi-type types like structs and arrays. We've also got pointers, which are like meta types as well. So there's more stuff, and there are many more. But once you've got structs, there's kind of like everything, you know. Even just ints and doubles, there's different kinds of ints and doubles and stuff in it. So you can look deeper into these things. You will eventually start using these as well. So there's actually ints. Not all ints are 32 bits. There's different types of ints you can make, which have more or less bits and stuff like that. So these are interesting. The type determines how much memory it will use, and also the way that it interacts with other types. So when we have a char in C, we can actually interact with it really similarly to an integer because they're both technically numbers. Variables can change their value. Variables can pass the value that they're holding into functions. Variables can be aimed at via pointers, so we can access them because all variables exist in memory somewhere. And then the other thing we have is constants, and constants have hash define. Constants are not variables. They do not sit in memory somewhere, but they are a sort of mapping between a name and a value. So they allow us to set values where they're set before our program is run, so they're set while our program is compiled, and they can't change while the program runs. So we set those as things, it's like, these are the fundamental aspects of the program, and they will be happening just in a particular way. So there's some simple variable code here. So we did mention, I mentioned a little bit of Dragon Ball Z. I actually finished rewatching all of Dragon Ball Z recently. That was a lot of fun. So Goku is 9001. If you get the reference, there's this really famous line in Dragon Ball Z where they say he's over 9,000. So I made it 9001. So we've defined that there, and we can declare variables, we can initialize the variables by giving them their first value, but this isn't just an initialization. This equal can be used to assign different values to a variable at any time you want. So I gave it a value and I can give it another value. I can actually give it the value from the constant as well. So everywhere where we see the all caps Goku here, we're going to see the number 9001 instead. So yeah, we can do the both together where we declare and initialize at the same time. Okay, I'm going to stop there for today. We do have a lot more stuff that I was potentially going to talk about today and more memes from people, but I'll go through those slides on Friday. So Friday's really going to be a speed run where I'm going to try to go through everything in the course in 2 hours. So a lot of it's going to get glossed over pretty quickly, but I do need to wrap this up here. So what I'm going to do is go into my be right back mode, finish off this lecture here, and I'll come back and answer some questions. I don't know if I need to answer questions. I think the Toms have been answering all of the questions there, but I'll come back anyway and see if there's anything that people need to talk about. Probably questions about the exam and stuff like that if I need to clarify anything. But other than that, we'll cut off the lecture for today here. All right. Thank you all very much. See you on Friday. All right, I'm back. Whew. That was a little tiring. I think it was because these last 2 lectures I always try to squeeze too much in, because I'm trying to squeeze the entire course into the 2 lectures, but I'm also trying to give everyone the prep they need for the exam. And I always end up talking for longer than I plan to on the exam, but I feel like that's worth it. I feel like at this point, there's still a lot of stress about the assignment, obviously. But there's a fair bit of stress about the exam, and I feel like if I take on a lot of stress to try to lower your stress about the exam, maybe it's worth it. So I think putting a little bit extra time in there on the exam still helps you. Hamish is asking an interesting question. How do you hash define a magic array? So you're trying to hash define an array with a certain amount of information in it that will never change. This is outside of what we do in 1511, but it is something that's definitely used a fair bit in C. It's called an enum. It's not quite the same as a hash define. It's actually closer to a struct than it is to a hash define, but you can actually define a sequence of values that is always going to be used specifically as that sequence of values. So the concept is an enum. I don't know if this is necessarily, like, I always look at these things and I'm just like, is this actually a tutorial? I just clicked on the first link in Google. Not sure if I should do that publicly on my things, but you can do this thing called enum. So you can see very much how the format is exactly the same as a struct here. So you can actually set it's like a sequence of hash defines in a row. So you can do enum, the name for it, and then a series of these things. So you can actually, in a sense, it's not the same, but in a sense you can kind of do a hash define sort of thing. You can do a series of hash defines that are this number, then this number, then this number, then this number. and you can set them up as specific values as well. And then when you use them, you can go through and say, change things in them or print out stuff in them and stuff like that. So I'm not going to go into too much detail, but you can do stuff like this. So when you do this January, February through to December, this is going to be 0, 1, 2, 3. Each of these is basically going to get hash defined as an integer that just goes in sequence unless you specifically say it's something else. And then you'll be able to actually loop through them like so. This is a for loop. It's not that different from the while loops we use. This I++ would usually be in it somewhere. This is actually really bad code because I haven't put brackets. It's not bad code, but it's like super awkward. Because you're going to like sometimes think, oh, where is this for loop ending? And it's not clear, but you know, style's different. One thing that I was laughing about was someone was talking about, you know, style difference between different programmers. And I think basically if you took any two programmers anywhere in the world, put them together and said, like, you know, have a discussion about what style is the perfect style to do in programming, it's basically how you start a fight. Because there's no two programmers that think the same style is exactly correct. We get it easy here in CSE because like everyone ends up doing my style. So I get it really easy because if I want support for my style of programming, I've got something like 4,000 or 5,000 people who have just gone through in the last 3 years who have only seen my style of coding and so will follow my style of coding. But I would be like, you know, like there'd be plenty of people who would be quite successful in being able to argue that my style should change for different purposes. But anyway, something like an enum is how we could do a collection of information like that in a hash define. It's not a hash define, it doesn't have the hash, so it's not the same. This thing, as far as I remember, it will actually appear in memory. I think it will actually, I don't know if it has a memory address. I haven't really gone deep into these things to see, but something like this might work. Yeah, so Hamish, hopefully that's yeah, so you're wanting an array that you could copy using memory and pass a pointer to it. I would consider just making the array in that case, like just memory allocating the array. But I think that the issue is you want this thing to be global in a sense and to be passed around. But even if you do, if you don't make it global and you just put it in your main function or something like that, as long as you're passing around pointers to it, that's enough. You know, because something will be accessible to any function that's given the pointer if it needs it, and that's okay. Okay, so Blake was, I'll close this, go back to my slides. Blake was asking a question there. I have an assessment issue with the extension. So the extension of the assignment 2, I assume. An invalid file name is handled differently between the auto test and your code despite it using a pre-written function. I don't know if this is to do with the new file that came out, Blake. I assume this is from the saving and loading stuff. So one of the things that we noticed was happening in the saving and loading is we were sending a message to the standard error stream instead of the standard output stream. And actually two different streams. The standard error stream tells auto test that an error has happened in the code, and so we were just sending out a message saying I think it was, which one was it? I think you were if you were trying to load a file that didn't exist, which I think would be similar to the invalid file name that you're talking about there. So if you're trying to load one that didn't exist, it was going to pass an error out in the main file, because it actually pipes it to standard error. You can see it if you look in the output. And what that was doing was making auto tests fail, as opposed to if you did a printf or something with the same message. And so we changed the main file, so I don't know if you'll need to update your main file. There's a change log both on the assignment spec as well as the I think in the file itself, it's either in the main file or in the H file that the change. It should be in the main file, the header comment. It'll say whether it's changed that or not. And so that thing was causing weird issues where if people had written code to handle the invalid file, then it was even though you're printing out the same text, because one of them was like this different stream, which is like an error stream versus an output stream, they were causing issues. So you might want to have a look at that and see if that's the issue. I don't know if it is or isn't. Like, so Eleanor was saying, for variables that was only used inside one function, should we change to a constant instead for style? It depends on the what that variable needed to do. If it was a variable that was a value, like this value here, that was never going to be used in any other way. I mean, this is a weird one because Goku's power is actually variable, but that's a story issue. I just wanted to put over 9,000 in this slide. So that's a different story issue. But if you have a number that's never going to change and is never going to be used for any other reason, it's probably good to have that in a constant. But if you have something that is set up sometime during the program and there's still only passed to one function ever, but it's set up sometime during the program based on other things which might change, then it definitely needs to be a variable, right? Because you don't know what value it's going to be before the program runs. If you do know what the value is going to be before the program runs, and then you're never going to use it except in like one place where you reference it. So for example, like the easiest one is like a hash define for pi, and I never use it until I do a particular bit of circle maths. And otherwise I've been passing it into a function or something like that from a variable I set up. Otherwise I can say, no, this is like a universal value, and it's important for lots of parts of my code, but I'm not going to use it for other things. Then I would potentially use a hash define. It's a bit contextual whether or not you use it, but the way that I often think about it is, if this variable never changes in my code and is never needed to change in any way, then it's quite likely that that is something that can be a constant. But again, this is a bit of a judgment call, right? This is the kind of thing where you need to try these things a few times and see. The thing that's always cluing me in that I need constants is if there's a number in my code. If these numbers appear anywhere in my code, then I think there's a problem. Because I should never have raw numbers basically in my code. If something is a value that needs to be numbers that will change and stuff like that, it'll be a variable. If it's an unchanging number that is going to be used multiple times through the code, like the size of an array or something like that, then I like them to be hash defines, like so. So still a bit of a judgment call, bit of a learning thing that you will like kind of need to decide sometimes whether or not they definitely need to be or not. Blake was being sad for snake case. Wait, did I do camel case somewhere? Oh no, you're saying that I use snake case, and so the whole... Well, the interesting thing is, I only recently standardized 1511 to only use snake case. Previously, 1511, I would switch between snake case and camel case in order to show people that there are multiple styles and you need to be consistent within one style while you're doing things. But I realized that wasn't a really great idea, because usually camel case or snake case is decided at an organization level. So you will like join a coding team of like, a dozen people working in a startup or something like that, or even much bigger, few hundred people working on a massive code base in a big tech company. Within that company, I don't know if it's like those big companies will definitely do that, but the small companies will definitely be like, here's our style guide. Everything that we do is going to be done in this style guide, and it'll be one or the other. So like that's the kind of thing where that level of consistency. So I was trying to teach people that there are multiple ways of doing things, but I realized it's probably better to be like teaching people that you're not just going to be doing things however the hell you want. Like there's so many ways to code, which is like, do it however the hell you want. And then they nearly always end up in ruin. Because like we can like kind of wish for this sort of freedom. for things. I noticed actually someone put a comment on the last lecture about like me not allowing global variables. I'm just like, not allowing global variables? You seem to think that like this is me putting you out and not allowing you to use the toys that you think are going to be like really great for you. That's like me saying to someone, here's a gun and it's aimed at your head and you shouldn't put bullets in it. And people are like, you're not letting me put bullets in the gun that I'm aiming at my own head. Because that's kind of what global variables are. There's very little that global variables can do for you other than make your code very, very hard to use. So I thought it was just really funny that someone was saying that, because it was just like, what I'm doing is trying to help you so that like all your program is going to be like really, really easy for you in the future and like really easier to understand, and you're not going to get into trouble. But you know, this is all part of learning. People are going to need to experience a lot of things and potentially destroy a lot of their own code and spend months debugging it before they go, oh, that's what I was supposed to do. And then they'll be like, oh, wait, Mark told me to do that from the beginning. Oh, well. Because there's another way of teaching, which I've always thought about doing this. I'm probably not going to. But of not giving people any guidance at all and just going, just try to do this thing. Just throw you into the deep end. Just try to do this thing. And after you inevitably fail, we'll sit down and have a discussion about this and talk about the ways that we can do this better. It does work. That way of education definitely does work for some people. So I go back and forth depending on the situation. Anyway, that's a bit much. Zihan Ye says 50 marks plus answer question 1 and question 2 correctly equals pass. Yeah, if you're trying to pass the course, the 50 marks, if you're talking about 50 marks for the entire course, yes. So you have to be able to do the hurdles, and your overall mark in the course is over 50, then you'll pass the course. I think Rich Russian Boy was confirming that as well. You said no, but I think you meant yes. Oh, unless you meant you're confirming it to be a slight clarification, but I think that you're both saying the same thing. Yeah. Okay, so Ben said, do we have to use VLab for the exam, or can we use VS Code? You can use VS Code and SSH for the exam. Anything that you've been doing in the course for writing your code, you can do for the exam. So the exam is going to use the same submission methods that we've got. I would suggest that you make sure that your code compiles without warnings and errors. So if you are doing it entirely on your own computer and something like GCC, let's go back to that meme. There might be things that you don't know are wrong, because GCC doesn't bother telling people. GCC is just like, oh, I just assume that, like, it's like kind of like using GCC as like you've reached the point where you can turn off all of the safety in your code and then just work without it. So if you are working with that, there may be things that you are doing that are causing issues. So make sure that you're compiling stuff with DCC just to see if our educational compiler is able to tell you more information about things that are happening and might be more useful. Oh, Blake, do I know what the current file version should be for the assignment? I'm not sure. So, version 1.5 of this spec. Updated extmain.c, such that testing a non-extant save doesn't cause auto test. I think it's meant to be existent. Save doesn't cause an auto test error. So, let's have a quick look. Do I have? I was just checking if I actually have this. All right. So this, because I'm in my CSC directory, this is a linked file, not an actual file like that. So that should be linked to ours. Oh wait, this isn't. I need the extension. Let me see what the I forget what the command is. Copy that. Okay, so this is the file that we're looking at that may have changed. .1. I'm not sure if this has changed or not. Might be something to ping Tom about, but let me just... Just going to look for... Alright, there's only 3 calls to standard error here, which means that this is the only time that that we're sending stuff. So this does have the correction, it just doesn't have it in the main file. So this should actually be a different version number. I'll let Tom know about it. What is it? It's command load track, isn't it? Yeah, so I think this is the line that used to be, rather than a printf, it was an error, and this is the line that was causing the auto test to always fail on this, as opposed to being able to actually test it. Could be this one, or this one. But either way, there's no error. So the current one is valid, except we haven't updated the changelog to give it a new version number. So what you probably want to look for is the standard error in it. Oh, you don't think that one's the issue, Blake? Reference prints something like name isn't valid, whereas mine says name isn't valid. So it's not this one. I assume it was one of the extension things. I'm not sure. You might have to ping Tom about this one, because he's the one that did the fix. From what I remember, it was that one of the extension load things wasn't was causing the auto test to fail anytime someone tried to load an invalid track. Yeah, as Ollie's saying here, stage 5, do load track. Second if structure, this one here, could not load track, which is causing errors. So this is the thing that's causing some errors. I don't know exactly what's going on here. I know that Tom has dug in behind it. I think it might take me a while to figure out exactly what's going on and get up to speed on what this is. I know Tom said, here's the issue, and explained it to me, and I have a vague idea of it, but I don't know exactly what it is. But I thought that the issue was that this thing was printing out to standard error instead of printf, which means the auto test was always going to reject it and say there's an error in the program, execution stops, as opposed to if we do the printf, then we can actually test for the actual string and see if that works or not. So I'm not 100% sure. We may have to dig deeper into this and make sure that's happening. So basically what was happening is that we were never auto testing if you were loading an invalid track. Oh, so the quotation marks are causing the issue. So this quote and this quote are different from what the auto test is. That's okay. So that's a new issue that maybe we've created that issue by doing this. All right, we've definitely passed that along. All right, so in the auto test, the reference solution is probably on the old code, not the new code, and so we need to update both the reference solution as well as this main. Actually, we may not need the main, but we just need to update what the auto test is testing for. All right, we'll get onto that. That's easier. I can understand what's going on now. Okay, so back to questions. I think there were some other questions back there. Sai Schrodinger is saying, you're getting a runtime error where the string is uninitialized or something located in the save.c, despite it being precode for extension 2, but it works completely fine when I manually test. I don't know. It's hard from just that explanation to be able to be 100% sure what your error is there. I think that I don't know if yours is the same issue that we're talking about here, but it looks like it isn't, because this looks like something that you're able to load normally, but there's something going on there. Yeah, it's hard. It's too hard for me from that explanation to be able to see what's going on. I reckon that's the kind of thing where obviously I'm not gonna I can't open your code here and show it. That would end up getting you done for plagiarism. But I think that's not a bad thing to take to a help session or something like that, to say, look, this is the situation. And it might be something where it's our issue, but it might be something where it's like your code is doing something odd and it appears to work sometimes or not, but I don't know. We'd have to dig to find out what's going on. Blake says you miss switch statements. I still use switch statements, but I only use them for really specific purposes. And I never use them when I'm teaching people the basics of a programming language. Because if you know switch statements well, you know that they really, really screw around with the idea of flow of code. Like if we're going to go line by line and follow a really specific set of rules about brackets and stuff like that, switch statements sort of blow all that out of the water, and they do weird things with the indenting as well, which is why I'm just like, nah. I want to get people, doing things well first, and then when you've learnt a good way to do things, you can then start screwing around with things and trying other things. Okay. Rakanovan says, wouldn't VLab VS Code be really slow during the exam since everyone's using it at the same time? Yes, it would be. But our computer support group knows when our exams are on, especially our exam, because 1511 is the biggest exam in CSE, and so they know, and they can actually behind the scenes allocate more resources to those. So it's not just going to be the standard set of VLab servers that will be running. I think there will either be extra servers running, or you won't even notice that there's extra servers running. There'll just be extra resources diverted to those servers in the back end. We have not done it with this many people before, because I think we're at like 860 or so, I think, people in the course now. I think we started off with just over 900, and now we've got 860, which is actually pretty good for attrition levels for a course. But yeah, so we've not done it this big, but we've done it in this order of magnitude of size. So I think that they have a plan for how this works. It has never been a problem before during the exam having load issues. I've seen it happen to other courses, but that wasn't specifically load issues. There was a mistake made somewhere on configuration level stuff, and then there was an issue. But we've been okay so far, so hopefully it'll be okay. Where am I up to in the questions? Okay, so chat was, I'm catching up to stuff. I think Blake and Sai Schrodinger are trying to figure out what was going on. So the loading of the track wasn't working in the auto test, but was in the manual test. And that's weird. Yeah, so I don't know exactly what's going on there. I think that what I would do if I were in a situation like that, where it's like it's working in the manual test but not working in the auto test, I would look really carefully at it and try to see what the difference is between the two, because there has to be a difference between the two, whether the auto test is asking for something weird or different or something like that, and see whether, I don't know, see whether there's a change or a difference. I think Blake and yourself are going through some different options there, but this is that debugging thing, right? So there's obviously something weird going on, and we don't know what it is. So when I hit that point, especially to this point now, where I have no idea what's going on, right? Things are really weird. Go back through the process. You know, the idea of like, there is a problem. So we acknowledge that there's definitely a problem. We don't know what it is, and we need to go through and start sort of picking it apart and try to find it. This is programming, right? I can't give you a better introduction to programming than to have at some point your code not work, and you to have exhausted a great number of different options and still not know why it's not working. Now you know what programming really is. This is like, I don't know how many years of my life have been lost to that style of issue. Okay, but you know, there is also an option that it's us that's the problem. So if more than you gets that issue, so that's the thing that we can always tell. We know really obviously if there's something wrong with our code when someone emails us and it's not the first time we've heard of that exact issue. If someone emails us and it's the first time we've heard of that issue, then it's like, you need to look at this yourself, because we have other people in the same situation as you and theirs is working, so there has to be something different. But you know, the second we get more than one person email us about the same thing, then we're like, oh, okay, we'll look into it. But I don't think that is an issue just yet for this one, so I think you might need to dig further on this one and see. Blake is saying that, oh, maybe there's multiple tests and they don't... Yeah, so a single run of the program should be able to do its own saving and loading. If you then close the program and reopen it, then it won't have the same thing saved. Maybe? I would need to actually think about this more carefully and look at the code. So Tom actually wrote that code, so I haven't looked exactly at what's happening with the saving and loading, and what it's doing with its files, and whether it's cleaning up the files afterwards or not, or it's keeping those permanently on the hard drive and stuff like that. So I don't know. We'd have to see. Yes, okay, so the comment here is, so much pain, I spent too much time on extension, I think it's time to call quits. So this is something that we get to, right? We get to this a lot, and I think that at minimum you should take a break. So once you're at that point, like, this is a level of frustration where that we will reach a lot of the time when we're coding, and it's a point where we will no longer be thinking exactly about what we're doing. And when we start to not think exactly about what we're doing, we won't be able to solve the problem. So the problem is not magically going to fall over from more effort. It's probably going to fall over better from a change of approach. And so what I often say to people is, when they hit that point, is the first thing they need to do is reset their brain. So I was going to say a nap, some exercise, a completely different way of thinking. So literally, like, you know, go watch some TV or read a book or something that is not program thinking, something that is not problem solving thinking. So I know I hate to say this, but don't play computer games. Computer games are active, abstract problem solving. They'll be using the same part of your brain, unless there's something you know really well and you don't really have to think about. But you know, try to get your head out of that space for long enough so that you've forgotten the details of your problem, right? So often that takes a nap, so it takes like hours, and then you'll be able to come back and go, I'm going to start this thing again, you know. And there's lots of little things. I'm actually going to be doing a seminar on this, but it's not anytime soon. It's going to be next term when I actually have time to prepare it, for CSESOC, which is like, how do you actually debug? Like, not how do you pick apart your code and try to find the errors in it, but what is the mentality around debugging that helps? I'll talk about that some other time though. Yeah, but yeah, it's tough. The other option, as you're thinking there, is like you're saying, maybe it's time to call it quits. It's okay to do that as well. You also have what are we looking at? It's not a week, but it's 4 days. Wait, Thursday, Friday. Oh no, 2 days. Sorry, I was like, because I was thinking about there's a deadline for some people goes through to next week, goes through to Monday, and I was thinking of that. But most people, it's going to be Friday. So, look, if you've gotten up to the extension and you're onto the second part of the extension, you've done heaps already. You know, like you've done enough. You're probably looking at a really, really high mark in the course by this point. There's other things that you can do with your life. This is like, this is the whole education thing that I try to do, which is like beyond what's in courses. It's like a real education is about how to deal with problems in life, and this is one of them. This is that, yes, I have put a lot of things out in the world in 1511, so I've put a lot of content in this course in case people are interested in doing it. It is not there as a requirement or anything like that, but it's also part of your education to think about how much do I actually want to do, how much am I actually capable of doing, how much am I capable of doing if I want to maintain less long-term sustainability of this kind of career path. And everywhere you go, you're going to meet managers who will do this thing because it's very successful. And I know I've done it before, is you find the busiest person in the company and you ask them to do work. Because the busiest person in the company is obviously the person that gets the results, because everyone keeps asking them to do things and then they get the results. So people go back to that same person and ask them to do things again. And if you end up being that busiest person in the company, the hardest thing that is to do is to, in a sense, feel like you're not the necessary person, the person that is there to go out and save everyone all the time. So you end up starting to get really, really fatigued by the amount of work that you're taking on unnecessarily, and learning how to hold that back and say, I have done enough here and I know it's not everything that I can do and I must stop, is like one of the hardest things to do. I have a lot of trouble doing that. I have a lot of trouble when I look at my email inbox and I have things in my email inbox from students asking me things that I've already told people. So they ask me something that I have emailed out to everyone a couple of times, and I'm like, oh, I could answer that because I could help this person. I could answer that, but I have to say no, I can't do that. Because if I get into a personal conversation with every single student in the class, then the whole subject will grind to a halt, because I won't be working on the lectures and I won't be working on the things that are dealing with 900 people. Instead, I'll be dealing with only one person at a time. And as we've talked before about my thoughts about saying doing an interview assessment instead of an exam assessment, I don't have the time to do that, and I will never have the time to do that as this subject scales. Even the smallest this subject has ever been in the years I've been here was about 300 people. It still wouldn't scale at that level. So I need to be careful about how I do those things, and that's something that's really interesting for you to learn as well, is that you need to decide when you're going to stop working and when you're going to like go back to living your life and stuff like that. I noticed in the Discord chat someone was saying the other day, it's like, I can't remember the last time I played computer games. And I felt really sorry for them, because I have boundaries where I'm like, at some point I will play computer games, and I don't care how busy my job is. Like, I would not allow it to take over my life to the point where it can take away the things that, that let me enjoy life. But it's hard, those lessons are hard, and a lot of people are aiming for the maximum possible marks that they could get, and that's pretty dangerous. So it's a difficult thing to work on. Anyway, sorry, I've ignored chat for a while I went on one of my tangents. Blake's saying that most difficulty in extension 2 is how auto test works. That's interesting. So I think maybe we can look at our auto testing, because it's really meant to be, the auto test is like not meant to help you that much. If you get to extension 2, it's meant to be like, here's the baseline. Maybe this works, maybe this doesn't. Now you have to figure it out, right? So hopefully the auto test is not being too difficult there. So Saishon said, no, you have no idea how I needed to hear that, but I usually need like a week rest, but that's past due date. Thank you. Alright, good. I hope you take a break. I hope you definitely take this afternoon off. Don't look at code this afternoon. There's really only a few hours left that you would have worked this afternoon. So my advice to you is, do not look at this code again until you've had a sleep and come back tomorrow. If you and Blake are in contact in other channels, maybe Blake can give you some more information from testing that they've done, hopefully, and then you can get some help there. Rokaneman said, spent yesterday stress baking because of being stuck on extension. That's a great thing. Cooking's nice. I cook only a little bit. But I cook dinner like maybe a couple of nights a week sort of thing, and it's actually quite nice, because it's sort of like you just follow the instructions and you make it work. So instead of being the programmer, you become the computer, and the program comes to you and you just do it, and it's kind of nice. Yeah. So that's kind of cool. Okay, so hopefully people are finding the stress level and the point at which you go, okay, I can stop here. And I should point out that there's plenty of people I know who had like a credit average in computer science, and then when they got to the end of their degree, they were like, why did I even bother? There's all these other people out there with distinction averages and high distinction averages. Why am I even trying to do this? And then 20 years later, they're just like, oh yeah, I'm like a upper level management in a large tech company, and my experience is valuable and it's been really good, and I can't even remember what I did in uni anymore, but what I do is important to this company and I care about what I'm doing. And it's like, isn't that cool? It's nearly like the marks system is important in that getting a pass is what you need to do a good job, and then everything above that is just chasing numbers, which may or may not mean that much. So, yeah. Oh, more stories about that kind of thing, trying to get people not to explicitly chase marks. I have a student who I've worked with in the past who is nearly at the end of their degree, has done internships with 2 of the major tech companies in Sydney. Actually, may have done internships with 3 major tech companies in Sydney now. 2 of the tech companies are currently fighting over this student. They're a credit average student, by the way. And 2 companies are fighting over this student because they did an internship with one company, got offered a job, and then they still got offered an internship with another company after telling that company that they had already accepted a job with someone else. They was like, no, we still want to intern you. And it's like, you realize that's of no value to you. You can't hire this person, they've accepted someone else. And it's like, no, it doesn't matter. We still want to intern them. They're still that good that we want to try to impress them so that maybe like 5 years later when they leave this company, they'll come to us. That's a credit average student, right? So marks are one thing, but they're obviously not everything. Anyway, I can say that a lot, but again, I put you in a situation where I'm still marking you. So I understand the irony in this, and it's a conflict within myself that I'm never going to be able to resolve. I'm trying to educate people, but I am in a system that is inherently punishing in ways that I don't like. So that's it. But it's either, it's either I like just lean in on the system of like boiling you all down into numbers, which I hate, or at least I will say things like this to try to convince you that there's much more to education than the numbers. There's only 13 people here right now, so there's not that many people necessarily are getting this. So you can tell we're getting to the end of the term, and I feel like there's things I haven't taught you, and I keep going overtime. We're now 45 minutes past the time the lecture is finished, and I'm still talking. And this is exactly the situation that I'm telling you about for you, Schrodinger, to take a break, because I'm not at the moment. I'm now overworking myself because I feel like there's more that I could do to help students. So it's exactly the same issue. So I'm trying to do more than I should, and I'm going to end up really burnt out this afternoon because of this, because I haven't eaten, and we're talking for 3 hours straight. It's really going to burn out my throat and stuff like that. So I should probably wrap it up on that note and say we should, sometimes work hard, but know that working hard to the point of hurting ourselves is not a goal. Not a good goal. Yeah. Okay, so let's see. You did it. Oh, Blake was saying they were doing some stress testing. You did 30,000 beats that were just 101. And Sasha said you've been breaking the test cases. Blake would like to see my switch code. I don't have any lying around right now. The places I used to use switch statements the most were input loops in games. So in a game, when you're doing a real-time game, you've got like 60 frames a second. So, well, old school. You can tell I'm old school. 60 frames a second. 144 frames a second. And in every one of those frames, you check if any keys or mouse buttons have been pressed. Switch statements are really, really good for that. Because it's just less code than if-else statements for that kind of thing. So I would do that. Oh, right. You meant Switch code is a Nintendo Switch. I haven't played the Switch in ages. I've just been playing heaps of PC games recently. I think it's because I got into management games again, and they're much better with a mouse and a keyboard. I just played the hell out of Jurassic World Evolution last weekend. So I built this giant Jurassic Park and had dinosaurs only occasionally eat the people. And I consider that a success. Anyway, I don't think there's any. Sai Schrodinger said you're grateful for my existence in your study life. So thank you for that. That's really nice. It's pronounced Skyry. Sorry, Skyry. Okay, I've gotten that wrong many times over the last couple of months. I apologize. Is that your actual name, Sky, or is it a tag that you use? I don't know. Well, I assume that Autumnal Blake is someone called Blake, and autumnal is like an adjective, but I don't know from people's tags on YouTube whether that's a genuine their name or not. Anyway, I should wrap it up there. We're like way over time, and I've got to go get some lunch and stuff like that. So, thank you all, and I'll still see you on Friday, but Friday will be the last lecture of 1511. All right. See you soon.